what I wanted to do. Okay, it doesn't like that. Okay. Okay, but the sound is off. No sound going on.
Where's the mouse? I go over there, it disappears. That's strange. Is that yours here?
Yeah.
Mm-mm. So when you're in presentation, hey Mike, do you know in presentation mode how to put notes?
It's actually in present. That's the problem.
You can't get this into presentation, right?
Right.
Well,
Focus, focus.
notes page.
It's not that. It actually, yes, it's not that. You have to go right.
Speakers, oh, so you want to see the notes like that?
Mm-hmm.
So, okay, if you click out of this there, I think you go into the slideshow and that presenter view.
There you go. Okay, so now.
Now, if you just
put
go,
it in
yeah.
like
Thank you.
that. That's it. That's it.
Thank you very much.
Anything above that, I don't know. She knows. That's one little thing. That's not much.
Yeah. Here you go.
Thank you so much.
Yep.
Just so today, refresh my memory, because that's another challenge I have, is do you have breakouts today?
So not for after the close of the meeting
Today?
we have those two small meetings.
Okay, I might have to move one of them. I said 2:38. 2:38 will have to go to 2:39, which is identical room. And you have 2:35, the larger one, 2:39,
1:31 afternoon time.
What about tomorrow?
Well,
Tomorrow's
that's
a
gonna be
different
separate,
meeting.
and I got separate rooms, I'll be okay in that respect. 131 is gonna be challenged today
Today?
too.
No worries.
These two small ones, but I have options.
Okay, I don't even know, okay, and Alice will be the point person.
Okay, I'll chat with her. Perfect, thank you.
Perfect. And I think I'm gonna put the handles over here.
Okay, yeah, and those were really well.
So, and I'll look around.
You can just have it kind of on standby or on the corner if one goes bad or something. Never send extras.
Should, yeah, I'm just thinking about.
I'm clear of that.
Well, so I'll close out at, let me see if I can, oh, cool, okay. I'll do that. There's a folder right here. Okay. And so here's, so here's Fenn's. Okay. And then here's Chiton's. Here's Megan's. And here's the I don't know why they're in this order, but I'll help you. Don't worry. I'll come up.
How about if I pop them all up?
No, I don't think that's a good idea.
Okay, fine. Yeah, I'll just, my biggest problem is I can't do it.
I'll help you. No worries. I don't mind coming up and doing it.
Okay.
It's really okay.
So that's good. I'm gonna hit the
And
restroom and I'll be right back.
That's great. And
Yeah.
I'm going for about 20 minutes anyway, so.
Very good.
All right. Good morning. We'll get started in just a minute here. It's nice to see everybody today. So for those of you watching at home, we're waiting a couple more minutes. Our breakfast has run a little bit long today, and we will get started in a minute. Okay, well, good morning. I think we'll get started now. So I'd like to just mention a couple of things, follow up on a couple of just logistics and housekeeping items. There'll be a break mid-morning today, and then there'll be a box or carry-out lunch for those of you that are leaving. We do have a couple of other small meetings this afternoon, and we'll figure out, we're having a little room change, and we'll let you know about that at the break. Just in terms of follow-up on the poster session, we had just an amazing poster session last night. 18 or 19 student posters, and then a number of other posters from the Azure projects and planning grants. Some of those posters will be available up on the MBDH website in the very short future, and I encourage people who weren't able to be here to have a look at those. Some really amazing student-based research happening across the hub. So, and good morning. We've got two panels today as well. I'm going to give a short presentation. I'll try and speed through this, and then I'm happy to answer questions later. And I want to say I'm always available for people across the region or the country. Give me a call if you've got questions about the hub or you'd like to engage or collaborate on something. I actually answer my phone. So the panels this morning will be one from federal agencies to talk about programs that are relevant to the big data hubs and that might be of interest for people here. Now, we couldn't get everybody from across the federal government or all the programs, but we've got 4 programs represented here today, so I think that'll be of interest, and there's plenty of time for Q&A after that panel. The panel after that is a data science education workforce development panel, and we put this together to sort of do a 30,000-foot view down to a case study view that I think will be of interest to a number of people, both here in the audience and then out watching from elsewhere. And then I'll say that we're live streaming again, but we also are recording these sessions, and they'll be available within a couple of weeks through a channel that's run by the ISU team, and we're grateful for their work here. And we'll make sure we make the announcement of when those are available. So I'm going to do a very short overview of the hub. Many of you are new to the hub this year, or to the BD Hubs program. So I'll do a very short introduction to the hubs. I'll talk a little bit about the Midwest Hub and what we're doing, our programs and partnerships, and then how to get involved. So the National Science Foundation has launched the Big Data Hubs and Spokes program. They launched that in 2015. They did a lot of work ahead of that. There were meetings all ahead of that between 2012 and 14. And in 15, they launched the 4 hubs. We, across the hubs, have about $6 million invested in us, a little bit more now, actually. And we're all based at host university institutions. The Illinois base, of course, is in the University of Illinois Urbana-Champaign, and we've got affiliates through our startup grant, and I'll talk about that structure in a couple of minutes. And then in 2016, the Spoke Awards were made, and I'll give a list of that momentarily. So what's our charge? We are, as regional big data innovation hubs, we're charged with building and strengthening public-private partnerships across academia, industry, NGOs, government, and other civic organizations. And the interest there is to build networks of expertise and resources to address common, shared, regional and national problems in science and society, and to help also drive the development of a national big data ecosystem. In the Midwest specifically, we're focused on developing effective cross-sector partnerships and collaborations that are able to take advantage of data and data science and big data resources to solve or at least start addressing those shared problems. And we do that in 3 ways. We work very hard at cultivating community. So that happens directly through the Spoke projects, but also out of our MBDH office and partner sites. And also to build resource networks. And we do that by building partnerships and direct relationships with organizations that we can partner on to provide resources. We also are very interested in facilitating new approaches to reducing barriers and friction to access to data within data-to-decision systems, and I'll talk about that a little bit further. And then building capacity in data science and workforce development. So I'd like to take a moment just to talk about the team here. So again, we're based at Illinois. The main office is at Illinois. But we've got co-PIs at a number of institutions, 2 of which are not here. Well, they're here. I just didn't do a separate link for them. So let me point that out on the slide here. So at ISU, Sarah Nusser's the co-PI, and we've got staff here. At Michigan, Brian Athey's the co-PI, and we've got staff there as well, and Ina Cooper's the co-PI at Indiana, Grant McKimsey at UND, and there are staff that I've left off this slide that I'll name in a moment. At the main office at UIUC, Candace Turner and Laura Martin are providing project management. Alice Delage is doing community liaison work and program development. Keith Hollenkamp, who's here in the room and has been doing a noble job at our social media efforts, is here, and then we had a summer intern this summer. So my apologies to the staff for not getting them on here, but Jill Miner is at Indiana. Kevin is at Michigan, and Aaron Bergstrom, who's on another slide, is at UND. And so I apologize for not getting them up on this slide. Okay, so here's our structure and governance. We've got the original startup grant. Again, those are listed here. And then we've got a steering committee with monthly meetings made up of the leads from the Spoke and data science areas. And then we had an election last year and brought in 5 representatives from across the region to represent the broader community. And we have 2 additional at-large reps who are connected to regional and nonprofit organizations. I won't spend any time on the slide. I'm sure lots of people have seen this before. It is up on our website, and these are the priority areas of interest currently. I will add that we're beginning to shape those and bring them down to a more manageable set where there's actually linkages across some of these areas. So we now are talking about agriculture and food, energy, water sort of coming together, and there's lots of opportunities there for collaboration. So we'll be revising these on the website to bring a little bit more coherence and shaping of that and scoping of our projects. So we had Spoke Awards. We talked about this yesterday, so I won't spend any time here, but this is the original set of Spoke Awards. There are descriptions of these up on the MBDH website, and so you're welcome to go and look for more information on these there. These are the activities that these are the formal activities that we engaged in and helped support over the last year. I think, again, because we're short on time, I won't spend very much time talking about these, but not only did the local office develop some of these, but a number of these projects and workshops were held at other organizations. So this was done by MBDH, but in collaboration with NIFA. This was done by all the hubs together with the Big Data Hubs, the Big Data Research Program. And then we ran a machine learning farm-to-table program. Transportation was at Michigan. And then the most recent all-hands meeting for the DigAg project was held in Ames just recently. We've got some new grant activity going on, and I'll speak about the supplement in a moment, but we do have grants in review and in process, and so we'll continue to help drive program by writing new grant proposals over the coming year as we're getting feedback from stakeholder groups and our evaluation process on how the community would like to move forward. So we did receive a supplement this year to help us build out programming, provide some continuity in the programs we're already providing, but build out programming that is being driven by our stakeholder groups. So we're doing that in a couple of ways. Let me just mention again that we've got an evaluation process happening. We'll be sending out this fall a fairly large survey. That survey will be developed out of the work being done by Lizanne DeStefano, part in her work done here, running some focus groups and interviews, and we'll build out a survey, so you'll be hearing from us in a pretty large structured survey coming out in the late fall. On top of that, we've got a grad student coming on, or an academic professional coming on to help us build out a knowledge base and do some development work and communications on top of our web development. And then we're doing some new partnerships with a couple of our programs around providing train-the-trainer workshops through data carpentry. The local hub shop will pay for the training travel, but you'll see a number of data carpentry workshops happening across the region over this coming year. And we're launching a planning grant effort around a virtual resource center for big data at small colleges, small institutions across the region. And we've got a kickoff meeting around that this afternoon. So we have some partnerships underway and in development, and I'll give just two cases of that in a minute. But we are working pretty hard at developing partnerships with other organizations and institutions that are not simply for one-off events, but these partnerships are intended to be long-term and durable and provide activities and resources that will be of value to the community for the near term, but then going into the future as well, both around data science education and workforce development, but also at the frontiers of data science and big data. So these are a couple of the places where we're working right now. Some of these partnerships are focused just on pilot projects, but others are really developing longer-term investments for work we intend to do together down the road. So I want to spend a moment talking about the one in particular at the bottom here, and that is our partnership with Microsoft Research. And that partnership is across all the hubs. Vani Mandava from Microsoft Research has been working with the hub executive directors for upwards of, it's almost been 2 years now. And we spent a number of months together working on principles to support the partnership that would happen to provide projects across the hubs with large allocations of Azure cloud resources to support very interesting projects requiring analytics in the cloud and also movement of data back and forth between cloud services and local HPC services. So we've got 4 projects now in the Midwest, all different, using different kinds of resources. I'm not going to talk about the technical aspects here. We had a couple of posters, but these folks are happy to talk about the technical aspects if you contact them directly. We can even set up a call if people are interested. But the Brain Life program is sharing data and code in the cloud and running some analytics, providing access to containerized data, and then eventually some links to Jupyter Notebooks. Volkan Eisler is leading an effort on computer vision with crop yields. They're running robots through apple orchards to do computer vision on readiness for harvest. And so they've got a distributed team of people that need to do analytics at different periods of time, and so they're using their Azure resources for that. Beth Plaley, who was the co-PI at Indiana, she's now at NSF, doing new work there. Ina Cooper and Jill Miner will be picking up on this. They've got a project called Seed Train, which is to link PID, so identifiers on data sets into the publishing workflow for data and moving some of that up into a cloud-based service. And Anuj, who is here, who's got a new project that's rolling out, that's just launched. He had a poster last night. They're going to be working on putting traffic incident data up into the cloud to do real-time management. So I'd like to talk just for a moment about a new collaboration we've got going on with the National Data Service. So the National Data Service Consortium was launched in January of 16. We've signed an MOU with them to provide access to resources for the MBDH partners that are at no cost right now. There are a couple of different resources that are available, both a workbench for providing training services, so they can spin off virtual machines for live training, but then also a sandbox platform that will allow testing and interoperability of tools across that sandbox. So, is that better? Okay, thank you. Sorry. For those of you at home, sound problems on me. Okay, so this is the new collaboration that we're doing. So we've got a pilot running now between the big data for Bridge Health team, NDS and MBDH. And this pilot is looking at hosting active research data for use to enable researchers to use public data resources. The data's been moved into a Mongo database. It's a very large data set, and they're building sample Jupyter notebooks for people to be able to use and run analytics on this data. They'll also be putting a public beta of the workbench out, through the workbench out there, and testing all of this. And we'll see how this builds out and where this goes. But this will be up and running very soon. And in fact, there'll be a demonstration of some of the tools underlying this tomorrow at the Bridge Health workshop. So I'm going to wrap up in about 2 minutes in case there's any questions. I just want to mention we're spending a tremendous amount of time in data science education and workforce development. Some of these efforts are not workshop-driven per se. They happen in a number of ways. Some are actual short courses. Some are participation by me and other MBDH people interested in workforce development and data science, engaged at other national leadership events in this space. And here are some of these happening. So these are activities that the MBDH, these are, one more, there we go. These are activities happening that we are driving directly through the hub. These meetings here are national level meetings that are happening. In fact, you'll hear a little bit more about this in another panel this morning. These are national level meetings where we're engaged with people who are leading efforts in the development of cutting edge data science education. And then also we provide consultation and engagement across industry and academia around development of workforce and curriculum. I guess I would add that we're happy to do more of that. And so if people are developing programs across the hub region, we're very happy to participate in that. So I want to mention there's an upcoming meeting at the end of this month, the Agriculture Data Integration meeting that is being hosted by UND and the University of Minnesota, Twin Cities. It'll happen in Minneapolis on October 26th, and there are additional meetings, co-located activities happening there, including Campus Champions Gathering. Campus Champions are working in HPC at the campus level across universities. So they're Exceed Campus Champions. And so this is happening for those of you that may be interested to attend that, and a data carpentry instructor training meeting for primarily undergraduate institutions and tribal colleges. I'll note that there is travel funding available for that, and please contact Aaron Bergstrom at UND if you are interested in participating. We talked a lot yesterday about the National Transportation Data Challenge. I will just highlight that there is another meeting happening in LA that's coming up if anyone's interested, and then the grand finale, which we talked about yesterday as well. And our team on Bike Share will be there, hopefully participating as well. This is the next to last slide. I want to mention we have a number of events happening across this academic year and into the summer. We'll be posting these, of course, on the website and in our newsletter, and we are very happy to help people participate and get information out about other related activities happening in the region around big science and big data. And please feel free to let us know. We have a newsletter out every month now, and we're really happy to be able to advertise related events in that space. So here are opportunities to engage. I have added just a couple of additional areas that we're growing some resources in. So first of all, we've got our mail list and newsletter, and I will say that our mail list runs about once a week just for announcements about activities happening, webinars to make sure people don't miss opportunities to engage in learning in that space. We will be continuing activities around webinars and community calls. And we've also are looking for new partners to develop additional pilot projects with some of our technical partners. So if there are projects where you'd like to use some of these technical resources, feel free to be in touch with us. I just want to point, these are the executive directors of the other big data regional innovation hubs. We'll be hearing from Renata Rawlings-Goss, who's the co-exec director at Georgia Tech, and leading that Making Data Science Broad. She'll talk a little bit about that later. So thank you very much. I'll be here for the rest of the day and tomorrow if people have questions. I think we have a moment for any questions now before we start the next panel.
So one of the areas you had as an interest area on the general hub was network sciences. Was network sciences?
Yeah.
Can you talk about what the Midwest is doing in terms of that, or what the interest is in terms of doing things with them?
Yes, I can, but I'm also going to see if Val is here and would like to speak to that. Val, there's another mic right here on this table. Thanks, Joe. There's another mic here so that we can all hear, and it'll get picked up in the. It'll also get picked up in our live stream as well. Thank you. I'm actually going to turn it over to Val, but so network sciences was part of the original grant proposal. The Institute at Indiana was driving both research in that area and proposals in that area and basic research in network sciences, but also providing linkages for network science technical support and development and applied research with other grants of interest in the area.
Well, something more about us. We are based in the IU Network Science Institute in Indiana University, and as part of our what we call the catalytic model is to help promote collaboration between network science in different realms and in different silos. So we're open to collaboration, and anyone who has any project remotely connected to network science, I would encourage to please drop us a note, and we would be glad to start working with you. And also you can visit on our website, iuni.iu.edu, and see about many opportunities, workshops, and seminars that we are organizing in the area as well.
Thank you, Melissa. I had a question about cross-cutting topic areas.
Yes.
Is there any panel or is there a working group that is organized to do outreach to cross-cutting groups that, for example, look at Internet of Things across the health science, holistic health, health science, and bridge health and neuroscience areas? So
to launch some new activities.
Right, or network science for traffic analytics.
Right, so that's a great question. So there are two ways to help us engage, and give feedback so we can launch some of those calls. The evaluation form is perfect. You bringing it up here is great. So we have some calls already lined up for this fall in a couple of areas, but we're really happy to drive some additional ones. So if you use the eval form or send us email at info@midwestbigdatahub.org, we're happy to set up calls and drive some of that to help support new collaborations and activity in the area.
Thank you very much.
Thank you. So I think we'll leave it there. We've got a full panel coming up now, and if you'll bear with us, we'll make that change now, and thank you all very much.
Melissa. Good morning. I'm Sarah Nesser. I'm at Iowa State University, and this morning we're going to have 4 presentations about federal funding programs related to the work of the Midwest Big Data Hub. And what we're going to do is have about a 10-minute presentation from each of the 4 speakers and have a little Q&A after those individual talks, but we'll also have 15 minutes at the end to have a broader discussion. Our first speaker is Fen Shao, who is the program lead for the Big Data Hubs and also program coordinator for Secure and Trustworthy Cyberspace Program. And so she's going to speak about both the hubs and cybersecurity programs. Fen. And this is NSF, if you didn't know.
How's everybody doing? Awake? All right. So I'm going to give just a little bit of an update about the Hubs program. As Sarah said, I lead the Big Data Hubs and Spokes program at NSF. So the Hubs program, of course, as you heard Melissa talk about, sort of 2-phase. There's the Hubs programs themselves, and then the individual spokes that we have continuing grant solicitations for. So I'm going to kick off with just a little bit really of an update on the last round of spoke proposals, what was funded not just here but across the country. And then I'm going to talk a little bit about the SATSI program, which I also help lead. That one is NFF's premier program on cybersecurity, and it has quite a bit of overlap with big data. For example, most of our privacy research is funded out of our cybersecurity portfolio. So anybody here who's really interested in that aspect of big data big data research should be proposing to SATSI. It's Secure and Trustworthy Cyberspace. Like the Hubs, it's a research program, unlike the Hubs, but it also has a sort of a transition to practice applications area. So I'll talk about that after the spokes, and then I'll try to keep things really brief and give everybody just a very quick overview, but I want to leave it open for your questions. So we just closed the most recent big data spoke solicitation was 17,546. The proposal submission deadline was the 18th. That was extended for some of the folks who were in the South because of the 2 different hurricanes. So things are just slightly delayed in processing these proposals because we're still waiting for Texas and Florida and a lot of the southern states to come in with their proposals. So just wanted you to be aware. We're anticipating somewhere between 10 to 20 awards at a total of about $10 million this year. So over the course of the last few years, there's been over $20 million invested in the hubs in total, hubs and spokes in total. So this round we have both medium grants, which go up to $1 million, and small grants, which go up to $500,000 each over the course of 3 years. And you can note that we say 10 to 20 because we didn't actually predefine how many mediums and how many smalls we were going to. Really will depend on all the proposals coming in. So from the last round of spokes, now I just talked about the proposal submissions that just came in, but from the last round of spokes, we funded a whole bunch of proposals, about $12 million in that very first round, and you can see the breakdown in the regionality is pretty much even up to a sort of integer amounts, because things don't divide completely evenly given those amounts, but fairly even within the 4 regions. And the percent funding per topic area, really, these award rates for topic area were dependent on the number of proposals that came in. So we saw a huge number of proposals in smart cities, a very large number of proposals in health, around sharing, reproducibility, data sharing. Also a large number around the environment. And this includes, agriculture, but this also includes geosciences, hydrology, energy as well. So we often think of it as the nexus between food, energy, and water, and when we think about the environment. We also funded some other grants, some smaller grants in cybersecurity. We funded individual proposals in material science, neuroscience, and education. So if you want to see the geographic breakdown of some of the spokes that were funded in the first phase, you can see that there's a lot of dispersion here, and definitely a weighting towards population a little bit. So, but it's fairly evenly distributed throughout the United States. In here, you can also see that there were planning grants last year, which were $100K, and the full spokes, which were about $1 million. And this year, we're not doing planning grants because the planning grants plan for the next phase of the spokes. While we do consider this a continuing program, as we look to the first 3-year period of the hubs and spokes, we're trying to figure out what will be the next solicitation after this one. What would it look like? Things may change a little bit. And that's really based on your response. So if you have any suggestions on what you'd like to see from the NSF in terms of what the next round of spokes could be, the different mechanisms where we can support you, the sizes, I'd love to have that conversation with everybody here. Oh, look at that transition. I didn't expect that. So now we're going to move on to the, I hope that's the last one, but I can't promise. I'm going to move on a little bit to a very quick overview of secure and trustworthy computing. SATC is a very large program at NSF. Every year, we fund about $75 million in awards to SATC, and that ranges from workshops and travel support to what we call frontier scale $10 million grants to large frontier scale, sort of center scale, just under center scale awards. SATC is very diverse. When we define what does the program mean, well, we define cybersecurity as involving hardware, software, networks, data, people, and integration of the physical world to cyber-physical systems. So cybersecurity covers all of that, but it also covers the sort of social aspects. And we consider it really a multidisciplinary kind of program. So we think about human behaviors as well as the technological aspects of cybersecurity. And so, oh, too bad. There's more transitions, but look at how nice that one is. That's the reason it's supported by 5 different directorates. So SISE, where I am, the Computer Information Science and Engineering Directorate, is the lead on cybersecurity. But we also, funds come from Education and Human Resources. We have a very large program. It's all about scholarship for service, being able to educate students in cybersecurity so that they can go into service in the United States government, and also lots of other sort of education about how do we train students around cybersecurity. We've got support by engineering, by math and physical science. For example, engineering is quite focused on security of our various networks, our grid networks, our electricity networks. Math and physical science are very interested in cryptography and the sort of fundamentals of security. And of course, social behavioral and economic science, which is really interested in the sort of human aspects of cybersecurity. And so if we really want to break it down, and I realize this is not a slide for anybody who has sub-2020 vision, SATC is a huge program, and it covers just about everything. Really what you want to do is you can take a look at some of the most recent solicitation, and there'll be additional topics on really what are the topics of interest, the hot topics that we see in this field. But also, if you have a topic that's in the area of, say, privacy and data science or around cybersecurity, or broadly just around cybersecurity in general, not having to do with data science, because I know people here have multifaceted research careers, please just take a look at the solicitation and then contact your program officer. See if your project idea is a good fit. If it's not, they'll probably point you to the right program for that idea. And so hopefully I can make these slides available. This is a list of actually the names within the SATC program and their area. So if you really want to, if you have a specific topic within an area, you can reach out to that specific program officer and NSF. You probably noted that I didn't put my name on there, but you can reach out to me too. So this is my name and this is my telephone number. If you have any questions about hubs and spokes or about cybersecurity, or just, you know, I can be your primary contact for just other project ideas and you're trying to find a place at NSF with. We cover really, through spokes, a huge number of data science related technologies, but also those application areas. So, I mean, Melissa's talked about neuroscience, we've talked about bridge building, right? And so if you know, and NSF's a big place, so I open up my phone number to you freely for you to contact me if you really want a pointer to where we can best support you here at the foundation. And I think that's my last slide, so I'll keep this up so you can have this. And should I sit down? All right. I can sit up front.
Yeah, no, go ahead.
All right.
You can stand right there. Questions for Fen? I wonder if you might, thank you. Good morning. Fen, I wonder if you might talk a little bit about where you see the Big Data Hubs program going.
Sure.
That doesn't work.
Does that not work? Okay, great. So like I said, the hums are designed, actually the first inspiration of the hums came out of a presidential initiative called the Big Data R&D Research and Development Initiative within the Obama administration. And one of the reasons we established the hubs is because we saw all this great activity going on, but we wanted something that had longevity past presidential administrations, right? So we started the hubs so that they could be community-driven nexi, for doing these collaborations, for driving both the research forward, but really driving the research forward through working with end users, working with use cases and applications. And that was the thesis of the hub. And so I'm very glad we established the hubs because the administration has changed since then. And I think the hubs are really pushing forward that initial vision of what big data has to be. And so, or big data research, big data innovation has to be in the nation. So we do see the hubs as a continuing program. NSF has sort of invested heavily in the sort of what we would consider the seed stages of being the hubs, but we wanted to give the hubs a lot of flexibility to figure out where what the needs are in the community, and to discover what the interesting and innovative things could be for the community, and to support that. And that's why these all hands are really important, and those feedback forums and having conversations with me and Melissa and the other NSF folks here are very important, because we have to develop what that next phase looks like. It's a continuing investment, so the hubs are funded for 3 years. We'll fund them for at least another 3 years and continue and sort of try to make that a dynamic process. Certainly we have intentions, although nothing can ever be settled in the federal fiscal climates. Nothing's ever settled until the day that Congress signs a bill saying that we actually have money. But to the intent of what the NSF would like, we do consider this a continuing program. And so we are sort of exploring what the role of NSF is in supporting this, what the role of other institutions, foundations, what the role of other sources of funding will be for the program in the future. But we do intend to continue supporting this through NSF for a number of years in the future.
We have time for one more question, if somebody has it. Did we get the AV figured out? Okay. Yeah, okay. I'm sorry. So I think if you want to stay up here, or you can take a seat. We will next have Chaitan Baru, talk to us about NSF big data programs, as well as the other things that are going on in NSF around big data research and data cores. Thank you.
See if I put my stopwatch on. See
Oh,
if I
okay,
can
yes.
hold myself too.
I'll wave my hands.
Good, thanks.
There's a big clock there, too.
Oh, okay. All right. Good morning. Very happy to be here. I've been here since yesterday and greatly enjoying this meeting. Also, my first visit to Nebraska, so one more state down. I counted as, if I spent a night in the place, so I think I'm now down to 38. I got 12 more to go. Excuse me. What I'm going to do is tell you a little bit about the big data program. There is the big data research program that NSF has. And then some of the activities that hopefully you'll find interesting and maybe want to get engaged in, and which all in some sense reflect one of the NSF big ideas that you might have heard about. There are these 6 big research ideas, one of which is called Harnessing the Data Revolution. And some of the things I'll mention are all sort of part of that activity, and I guess will give you an idea of some sense of sort of the trajectory of where things might be going. So the big data program, actually, Fen mentioned the big data presidential initiative, which got this kicked off in the previous administration in 2012, 2013. Initially, it was joint with NIH. When we first launched it, it's interesting to see sort of how the format of the program went. By the way, I've been at NSF for 3 years now, so this was launched before I was there. And it's interesting to see how the categories went through, because in the beginning we thought, oh, there are these very specific areas of big data that we should call out in the solicitation and expect proposals and so on. So in the first round there were 6 proposal categories. I didn't put all of them here. And then by the time 2014 came in, sort of what happens when you do that is either you get responses or you don't, for one thing, right? People are not sending you things in certain areas that you thought, or people are sending in so totally different areas. So you sort of relook at that. So in 2014, there were 4 categories as it shows. So it's basically analytics, data management, computational science discovery, innovative applications. But 2015, we cut that down and said we don't even want to specify that. So fundamentally, it was foundational proposals versus application-oriented, sort of innovative applications proposals. I'm not going to go into the details of what the solicitation says and what all the requirements are. Some of you may already have seen it. But basically, one of the interesting things there, I guess, is the mix of proposals. So back in 2015, we had 63% of the proposals were foundational, 20% were innovative applications, and at that time, we also allowed this combination. So sort of allowed people not to make up their mind, right? So I'm foundational and I'm innovative applications. So there was about 17% in that category. 2016, we decided there are basically 2 categories, and you have to make up your mind where you fall into, and it does in some way matter because sort of the way we review it and so on. So the foundational and innovative applications were 52%, 48%, and by the way, the percentages we feel like are going in the right direction in the sense that right from the start, big data, as you all know, is this area that sort of sits in between disciplines, right? It sits between the sort of technical disciplines like computer science, statistics, and so on, and what we might call the application domains. All the things, many of the things you heard about yesterday, agriculture, social science, et cetera, et cetera. So we were actually wanting more on the application side. And this year, we finished the reviews. I'm not sure if all the announcements have gone out officially. The decisions have been made. It is a 40-60 split. So I think that's good. 40% on the foundational side and 60% on innovative applications. Foundations also comes, by the way, in other places at NSF. So it's not like we are shortchanging it. There is computer science has its core programs, statistics have their core programs, and I'll also mention the tripods program that we launched. The new thing that we did last year was this partnership with the cloud providers. So Google, Amazon, and Microsoft each provided up to $3 million total of cloud resources. So this year, I think something on the order of 9 or so proposals that got funded actually made use of that ability. And some of them are using quite a lot of cloud resource. So that's something we are actually interested to see how that will proceed, and the idea is to, of course, continue that option next year as well. In terms of the trajectory, if you again read the solicitations, I think the original solicitations were in some sense very classic big data kinds of things. And well, the big picture I would say is in some sense I think we are moving from this whole thing being big data to what we think of as data science, which is a much broad. Now, different people have different definitions of this. Our way of thinking is data science is the broader thing. It's not the narrower thing. And big data is sort of one piece of it. And the original solicitations would very much emphasize these classical notions of, by now classical, 5-6 years ago, velocity, variety, volume, etc. But of course, we get a lot of, even in those days, we would get proposals and increasingly more of, just proposals that are talking about dealing with messy data, modeling real world with underpowered sort of data sets, what are all the trade-offs. And then some of the bullets I put there are some of the areas that we think would be emphasizing going forward. And there was some very good discussions yesterday, including the panel that was here, talking about issues of fairness, bias, transparency, interpretability, trustworthiness, and sort of understanding that whole thing, right? So it's not like everything needs, there may very well be applications that are just quite happy with black box approaches, for example, and that might be just fine. But you might also want to have these other properties available. Also, looking at the full life cycle of data. So not just the analytics part, the thing that happens before that, which is all the transformation and the cleaning part, but also the thing that happens after that, which is the decision support and the policy making, data-driven policy, and all those kind of things. So I think that's sort of the expansion. A couple of other things I threw out here, again, these are in terms of sort of the trajectory of thinking about this. So the line I have is, data is to data science as computers are to computer science, right? You can't do computer science without computers, and you can't do data science without access to data. And this is real data that students, researchers can get their hands on. So that implies that we have to find ways of making data more accessible. And it's actually not just data, it's also the knowledge structures that come out of it. And so there is this notion of sort of thinking about, another way we talk about it is, you have research with data and you have research on data, right? So all scientists are basically that's what we do. We do research with data. But data science is this thing that sort of takes a step back and looks at this in maybe one level of abstraction. And so we need to have access to those things more or less as infrastructure so that you can use it in your classrooms, use it for homeworks, use it in your research, and so on. And also the other one is this notion of translational data science, which I'll come back to. I have a slide on that. So quickly on the tripods, am I already over time, Sarah? I have to... Okay, so I'm having to rush through this. So Tripods is the program that we just funded. In fact, next week is the first kickoff sort of PI meeting going on in Washington, in DC. And it's our program that sort of explores the foundations of data science, requiring computer scientists, statisticians, and mathematicians to come together. I'm not going to go into all the details other than to say that there are actually 2 of the 12 that were funded that are from the Midwest region, in case you're passing things along regional boundaries. One from Ohio State and one from Wisconsin. So I won't go into the details. So translational data science, so if you think of then the foundations and theories of data science on the one side and then the application of it, the act of sort of applying all of those in practice, we think is a activity that's worth exploring and examining. Okay, and again, there was a lot of discussion in the panel yesterday when people were talking about synthetic data sets versus real data sets, what works in the real world, what works in a challenge competition, and that there's a big disconnect a lot of times between the reality and so that whole area for us is the translational aspect. And it's also closing the loop from the practice to the theory. So once you learn something in the real world, you have to come back and say, well, how do we fix our theory? So we had the first workshop of that in Chicago, which was led by Raghu, I think he's here, Professor Raghu Machiraju from Ohio State and Bob Grossman from Chicago. The second one is coming up in November 13th, 14th at Berkeley, led by David Culler. And we're planning a third one maybe sometime in March. That'll be in New York City. So along these lines of building infrastructure, another idea that actually came to us from the community, specifically from Andrew Moore, who's the Dean of Computer Science at CMU, Ramanathan Guha, who was also VP at Google until he retired, all came to us with this idea that very large-scale knowledge graphs are being built out in industry and being used for cutting-edge applications that you and we're all using and benefiting from. And the notion was, shouldn't we have something like this in academia that's an open-scale infrastructure? So we thought that's interesting and intriguing concept. So we've been having some meetings around that. In fact, the next meeting is the one I'll be attending tomorrow. So we have a meeting coming up in the next 2 days, tomorrow, day after, and it's going to be at the National Library of Medicine, NLM. And in fact, it's being done sort of under it's hosted by an interagency group called the Big Data Interagency Group. And there'll actually be presentations there from NIH, DARPA, NASA, NIST, and NSF, all talking about what investments they've already made related to this, over the decades, really. And to see if something can come together and gel going forward. Okay. The last one I'll talk about is we're also interested in sort of on one side, really broadening the agenda for data science, not just having data science as something, a topic for research and education at the top research universities, but everything from sort of community college level onwards. And one of the issues with data science, of course, is getting your hands dirty with data. How do you get engaged with data? How do you get into real-world situations where you can get that experience? So this idea of data core was to try and connect people who are either students or people who want to help with data science with projects. So people who want to help might come either from universities, this would be your undergrad, masters, et cetera, students, or from industry. Or we also see a lot of people wanting to retrain themselves into data science because it's the hot new discipline. So they might be taking online courses and so on, and those people might actually want to do projects where they get experience so that they add to their resume saying, I actually did this practical project, right? On the other side, you might have projects coming from anywhere. They could be in academia. They could be your own research projects that require some kid or somebody else to come and help you with the data. They could be from government. They could be from international organizations. They could be from industry. So as we talk about this, we've found a lot of interest. In fact, just this morning, I got email. Our education director at NSF is very interested to collaborate with us on this. And we're also finding a lot of interest from international organizations. So we're going to have, let's see, the first workshop to, again, explore this concept. That's going to be December 7th and 8th at Georgetown University. So Professor Michael Bailey, who is a professor of public policy at Georgetown, is going to help organize that. And we have a good number of international organizations coming there, including World Bank, UNICEF, ITU, and a bunch of others. So it's interesting to see how this idea is picking up. So that's it. I guess if you have any questions at this stage.
Got time for a question for Chaitan? All right, well, we'll get you in the next loop. So our next two presenters are coming in remotely, and do we have Megan on the phone?
We do.
Okay.
Not Megan, actually. The next person is, Megan is the next person.
Yeah, okay. Megan, can you hear us?
You will now be placed into conference.
Okay.
To mute your line, press *6. To unmute, press #6.
Megan? I can't hear you.
Are you sharing the screen?
Is Megan here?
She's sharing on her end.
Okay.
Okay. Megan, this is Sarah Nesser in Omaha. Are you on the line?
She might be muted.
Okay.
Okay, try it now.
Megan, this is Sarah Nesser in Omaha. Are you on the line?
So I know she called in because she said she dialed in a while ago.
Okay. All right.
We've got a speaker change for the next one. But we'll-
Okay.
See what she says.
So is somebody calling her?
Someone's calling her. Is that what you said?
Yeah. How
Oh.
are we reaching out?
Megan, are you on? There's more people coming on.
Oh, we're muted.
Okay. Oh, good. Nope.
I was unmuted.
Muted.
It shows it shows people are dialed in. And they're not muted.
Do we have our next speaker on the line by any chance?
I'm not sure who's on the line. I think she said Megan dialed in, I believe, and then
Megan's in, and then David, are you on the line?
I think David's coming in at 11:45.
Right.
Okay.
Okay, we will, so. Well, while we're waiting for us to be able to connect, we actually do have time for additional questions from our NSF reps if there are questions in the audience. And we will continue to work on this.
Okay, so we have time for additional questions.
Muted.
And yes, sir. Let's see.
This is related to the data courts for Shitanti. Is NSF planning to fund these kind of like the Centers for Cyber Excellence and things? Like how is NSF looking to get institutions and academic schools or wherever actually engaged with being part of this core? So like you talked about this idea of having a core, but how are you looking to actually get people to engage with this and sort of share out these projects, et cetera?
Yeah, well, good question, and that's going to be part of the discussion at the workshop. In fact, some of the people that we are planning to invite are people who do outreach, placement of students, and also international programs, right? I should say that the idea of data core is for whatever the data core concept is to be extremely lightweight, because there's already a lot of things going on. In fact, right, Ghani was here yesterday, so there's Data Science for Social Good. Jake Parway, who runs this organization called Data Kind, is going to be at the meeting. And so they all see value in it in the sense that having a more coordinated thing, let's call it a central coordinated thing, actually helps all of these organizations as well. So as Raid was telling me yesterday, they're getting more and more requests and everything is a little uncoordinated for them right now. At the same time, what we see happening on the university side is there are a lot, at last count, there's something like 500 master's programs in data science across the universities, and there are increasingly more undergrad programs. So one sort of opportunity that NSF has is to connect with academia to sort of coordinate all of those. And so data core would be something that would be very lightweight to provide this kind of connection, and nothing much more than that.
So can I ask you and Ben to come down to the mics because we are not getting this on the mic.
there, I guess, yeah.
All right. So the other questions. So I wonder if we have a lot of younger investigators in the audience, and I think that many have opportunity to learn about what makes a good proposal in the generic sense, but I wonder if for the programs that you oversee, whether you have specific things that have really piqued your interest in proposals that might help people be more competitive in their proposals to the programs.
I can talk a little bit about just what are some of the characteristics of good proposals to hubs and spokes, or specifically spokes. Is it? Am I? I'm okay. So what we're really looking for in that particular call is a tie to the applications and uses of big data, and a tie to the people who might be actually using any sort of big data technology. You know, some proposals are very open in that they say, you know, they have it sort of, you know, if you build it, then they will come attitude, and those tend not to be successful. So talking to younger, you know, proposal writers, if, you know, you say you're going to build a platform for X user, then it would be mindful and wise to actually speak to the community of practice of those users or your user base and start partnering with them before you start building your platform. And that's, I think, part of the overall thesis of the spoke solicitation is that that idea of really working with the end users, working with other partners to think about what the platform needs to be, what the technology needs to be before you go ahead and start building something.
So one general recommendation, suggestion I would have, especially to junior faculty, as you say, is don't ever be shy to call program officers at NSF and talk to them about what you're thinking about. You'll at least get some sense of you know, the ballpark of the idea, whether it falls, whether it fits, you know, the kind of things. Also, visiting NSF is a good thing. So you know, most people at NSF are friendly, maybe all of them. So you should feel free to visit and talk. Then the other thing is, well, especially in the area of big data and increasingly some of these initiatives we are talking about, which are all going to be very interdisciplinary. I didn't mention the word convergence, but one of the big ideas at NSF now is this notion of convergence. And the convergence is that really all of these disciplines coming together sort of even more tightly than before. And this requires real collaboration. In fact, requires real collaboration even at NSF among directorates and program officers and so on. It's a challenge across the board. I think you can assume that NSF people understand it because they have to collaborate. So they have to see you folks collaborating on campus. So in those kind of programs, it's in a way maybe even more important because you may have to talk to 2 or 3 program officers, right? You might want to talk to the person in computer science, but maybe also the person in biology or social science, or maybe it's your colleague who's going to be the co-PI, et cetera, doing it. So I think having these conversations and getting a much better sense of that. The other one I want to say is, I used to think it's odd when I was not at NSF listening to these kind of things, but actually it's true. You should read the solicitation carefully. There are certain things put in there because, you know, people want to have those things appear. And so look at solicitations carefully and see if you can respond. And yeah.
That sort of more logistical suggestion is always submit your proposals early. Don't wait till the very last day. And I know that the difference of whatever you're honing of that proposal on the very last day is not going to make up for the fact that it may not be accepted because it's 5 seconds late. All right, so whatever reason, you know, and it's not up to the PIs. They don't realize that it has to go through their SRO. It has to go through all of these other folks who have to take a look at it. And then it may not be them that's late. Maybe that their office might be late or whatever their grants officer might be 5 seconds late. And you'd be surprised that NSF, you know, once it hits 5 p.m. proposer time, that system shuts down. You can't submit anything, right? You can't put anything in the system. past that point. So, so just, I think there's a lot of things, like Chiton said, read the solicitation, because you don't want to get caught up in the bureaucracy of the federal grant system. You want your ideas to shine. So learning that just takes time. And the first thing I will say is just submit your proposal a week early. That always helps.
Yeah, let me just add to that. This year we did have proposals that fell off the table because they came in after 5 o'clock, and there's just absolutely no way that those can be accepted. So.
Yes, sir.
Robin Gandhi, University of Nebraska, Omaha. A lot of these big data targeted proposals will have external collaborators because they're often the data owners. What sort of are good pointers to have commitments from them? I know collaboration letters is one way, but what are some of the good practices when such collaboration is being portrayed in the proposal? If you could reflect on that, that would be great.
It sounds funny, but basically what I would say is keep it real. So in the sense that, whatever you're doing should, when somebody reads it, it should sound like, okay, yes, they can pull this off, right? So if that means getting a letter, that could be one. If it's just how you explain it in the proposal, so it's just making sure that all the details are there. And as you were asking the question, I was thinking of we got a question. Somebody was going to get access to proprietary data, and they would not be able to publish anything that was at the micro level, but they could only publish aggregated results. And they had a question of, well, will such a thing be accepted? Yes, it could be. I mean, so you just need to make the case that why you're not going to be able to publish the data that on which you have done your research, and as long as things are properly described and make sense, I think that's fine. Now, because on the flip side, just having a letter may not help either if the letter looks like a form letter and doesn't show. So I think it's really, even if you have a letter, the part of what I mean by keeping it real is if the letter really showed some awareness of what was in the proposal and there's a linkage, then people do read these things seriously and people do keep in mind, is this just a throwaway letter or is this a real thing, right? So that was my point.
Yeah, on that, I think keeping it real on that note of being explicit about what that collaborator is going to do within the proposal, right? Sometimes people just write, we're going to partner, and that's the end, right? What does that mean? What is that partner actually going to do? What are they going to contribute? What is their task, right? I think that's the biggest failure point. And reviewers look at this. They say, okay, you have all these letters of collaboration, but we don't know what they're collaborating towards or on or what they're contributing, all right? So making sure that that's in the proposal description and being clear how that ties into the overall overall push of the objectives of the entire proposal, I think is really the best advice I can give.
Yeah, the other thing is, actually, this is an area where we are also, I'm sure we're looking for ideas from you all. This is, again, in the area of multidisciplinary collaborations. These are, as I said, hard to do, which means they're sort of hard to get started. And we've certainly had these kind of discussions at NSF is, how do we, so if you're coming in for $1 million, $2 million grant, then of course you're going to try and put everything in there, make it look very shiny. But what if it's the very first time that these two people are collaborating? And sometimes, and there may be a couple of PIs who have collaborated before, just because they've been around longer or whatever. And that proposal will tend to look better than the first time collaborators, right? Because it's case by case. I mean, sometimes it's not always true. But that raises the question of, well, is there a way to jumpstart these collaborations? So in the real world, people do have to walk across campus, have some conversations, or go to a different campus. All of that takes time and effort. And so if you have ideas, so one idea for that would be that you have small proposals or small grants that allow these kind of things to jumpstart, and then they can come back and do a larger one. That's just one idea. But if you all have any thoughts about how to get these going, and actually I was visiting Iowa State just a few days ago, and we were having conversations about this kind of thing, but on the data side. I mean, a lot of times when you're trying to do some data science research, you have to bring the data together. That itself could be an activity, right? You may not know exactly what you're going to do with the data, but the first thing you have to do is actually bring the data together, which might mean talk to a bunch of stakeholders, figure out where it's going to go. Is it going to be on the cloud? Do I have a server? That could also be thought of as preparatory steps to actually then doing the research. So I think even at NSF and all the organizations interested in multidisciplinary, we need to get a little bit more sophisticated about how this thing is going to work. It's not just come and submit one big grant and hope it gets funded. It's really a process. And then how do you support the process?
Yeah, thank you. I'll just add to this discussion that NIH has a very good team science set of resources about how you develop teams, what kind of roles and credit models you use, and so on. The other thing from my own experience is that the first NSF grant I got was a planning grant to connect with and deepen a partnership. This was with the University of California, Santa Barbara. Ultimately came around to San Diego, to Triton in a much earlier life. And so these smaller grants are a really great vehicle to really deepen things. Okay, do we have things sorted out? Or?
Explanation. They're on. They can hear us. So hi and thank you. We've got a swap out speaker. Dave Golke is going to be on for Department of Energy. Megan is on. They can hear us. We can't hear them. We're working on the solution right now. So while we're working on that solution, I think we'll have it fixed in a moment. If there are any more questions, I may have a question, but if there are any more questions, I think now's the time to do it. We'll just drop off the rest of the Q&A on the other end so that we still have time for those presentations. It's Tracy's in the back. Yeah, great.
Hi, thanks. Just had a sort of bureaucratic technical detail question on the letters, since you mentioned it. There was some guidance a year or 2 years or so ago regarding letters of support versus letters of collaboration. And letters of support are no longer allowed, but letters of collaboration. And along with that, there was some suggested language of a very brief letter of collaboration. And we've had some pushback from collaborators and others in our grants office and things that only that language is allowed in those letters. And I just wanted to get some clarification on those letters can be longer and can explain in more detail what that collaboration looks like. Is that true?
So some clarification on that. It depends on the solicitation, why you need to read the solicitation. So the general guidance is that we don't accept letters of support, we accept letters of collaboration, and this is the template of what it should look like. And there's very little on there because the actual description of what the collaboration should be in the project description, not in the letters of collaboration. Otherwise, people start tacking on dozens of letters of collaborations in your proposals, 20 pages longer, right? So the letters of collaboration is literally just to say, you know, we've signed off on this, and any of the information about the project should be in the description itself or in the other sort of supplemental docs that are required, right? Solicitations can allow for longer letters of collaboration. So the spoke solicitation allows the hub to have a more detailed letter of collaboration to talk about how particular spokes, when they write their letter of collaboration, how the topic area aligns with the needs of the hub, right? Other solicitations can allow for letters of support. So there are some, usually they're older programs that have allowed for letters of support. In their call, they say we still allow for letters of support. So it depends on the program that you're applying to. You know, if you don't see any text in the solicitation about this, then you can go to the general guidance, which NSF puts out every year, and you should take a look at it. It's usually NSF document 001, right? So that you can take a look at it, and that's the general guidance if there's no text about it in your solicitation.
Van, I wonder, you have a box-top view of all of the hubs, and I think they've taken different approaches to standing up spokes, number of spokes, and depth. I wonder if you might speak a little bit about the different models.
So I think they're different, but they're very much similar because the hubs all tend to have a fairly small, lightweight staff, and so whoever stands up as spokes are members of the community that come up and say, we'd like to stand up a spoke for this purpose, right? So there'll be leaders within communities, there'll be academics, there'll be industry folks that might want to stand up a particular sort of community of practice that they would consider some sort of spoke. Usually it starts out with some sort of small group that gets together before. They may have gotten together months before submitting a proposal to the NSF or anywhere else, or they may not ever want to submit a proposal to NSF. They might be just a standing working group that discusses, things that they want to work on outside of whatever NSF can support. So some hubs, the South hubs have a sort of a tiered system of different kinds of working groups. Some of them are more lightweight, some of them are standing working groups, some of them come up as community of practices. I know new working groups have come up as we've responded to these various natural hazards, right? So in quick response or rapid response groups, studying something using data science. So that South Hub has sort of a tiered approach. The West Hub has sort of a strong steering committee and then a series of communities of practices that I think are more stable and have been working for years along, but they do multiple things, right? They're broader topic communities of practice around data science storytelling or cloud resources, and then they pick various topics of interest that they want to focus on within that community of practice. So you can see, different structures, but really what it comes down to on every hub is there are subgroups, subcommittees that work on
You will
specific
now be
topics.
placed into conference.
Excuse me.
To mute your line, press *6. To unmute, press #6.
Hello, in the vehicle technologies office as well. It's, I believe the phrase that they've used is mafia, and we continue to keep it true.
Hi. Good morning. Good morning. We're good morning. You joined us midstream.
Hello,
Thank you.
Omaha.
Yeah. Hi. Good morning. Glad to have you here. So, we're gonna. Fen was just finishing up an answer to a question. We'll let Fen finish that, and then Megan, we'll have you go ahead. And Dave, thanks very much for standing in for your team. We'll see you in a minute, and we can see you. And if you share your screen, Megan, first, we'll be able to see your slides if you have them handy.
It would be my pleasure.
Thank you. Do you need to finish your?
Just the end of my thought is whatever the structure is, it really is about bringing people together in a small working group. None of these working groups are huge, right? The only way to get people to actually do anything is to have a smaller working group from anywhere to like 3 or 4 to maybe 5 or 6 people working actively on something. And whether the structure is standing, whether the structure is it works together just on a project and then it dissolves, I think it depends on the topic that you're working on.
Well, thank you very much. We're going to release you from the panel, and let's give a hand to our NSF colleagues. Megan, this is Sarah Nasser. I'm moderating the session, and we're ready for you to go. Megan is with NSF on smart and connected communities.
Hi, thanks, Sarah. Hi, everyone. Can you see? What do you see? You see my slides?
Yes.
Do you all see my
Yes,
slides?
we see your slides.
And you hear me? And do you see me?
Yes.
Okay. We're good to go. And how much time do I have?
If you think about a 10-minute presentation, and we'll have both of you do 10 minutes, maybe take a question afterwards.
Okay. All right. So let's jump right into it. So my name is Megan Houghton. I'm a staff associate in the Office of the Assistant Director within SIZE and at NSF. I work with Fen and Chiton, and primarily I work on the Smart and Connected Communities program. To flow right, let's see if I can do this. There we go. Okay, so I'm gonna provide a little bit of an overview, background on Smart and Connected Communities from NSF's perspective, but before I dive in on that, I'm going to take a step back and describe a little bit of the federal landscape and what the broader picture looks like. And then Dave will speak on behalf of DOE's Vehicle Technologies Office, also specifically. But more broadly, smart cities and communities efforts began across the federal government in 2015. Investments began on behalf of several agencies in different areas. Of course, NSF's role is in supporting fundamental research aligned with smart cities. This task force, the Smart Cities and Communities Task Force, was formed to help coordinate activities across multiple agencies. That coordination began in 2016. The logos on the slide represent the agencies that participate in this federal activity. One of the main activities of this task force has been to create a federal strategic plan, which is that in the middle of the screen. That was released in January for public comment, and a final document will be forthcoming that reflects the priorities of the various agencies aligned with smart cities and communities. Just to give a few examples, and some of you may be familiar with these activities across multiple agencies, the NIST Global Cities Teams Challenge, NSF. The Global Cities Teams Challenge is intended to enable cities to develop blueprints for implementing new innovations in their region. The NSF has played a role in supporting researcher engagement in the Global Cities Teams Challenge over the past couple years, and specifically we offered grants, we offered eagers for teams to participate. Of course, DOT launched the Smart Cities Challenge. Most noteworthy, I think, of course, they invested about cumulatively, they invested, I think, over $140 million, ultimately went to Columbus, which represents both DOT dollars and private funds that matched the federal investment to launch smart cities innovations in the mobility sector. And then NSF, again, in that case, we also do provide some researcher support to participate and engage in the DOT Smart City Challenge. A couple of our grants that will be announced from this first round of the program mention and have engagement with the Smart City Challenge team. And then the array of things in the city of Chicago. This was an infrastructure grant made by NSF in partnership with also the DOE National Labs participate. And the idea is to deploy sensors on a city scale to acquire data and then ultimately close the loop and make policy decisions based upon that data in Chicago. And this is scaling very quickly to other cities. There are many cities around the world that are interested in deploying these sensors, which the picture on the right in the circle is the actual the sensor unit. Charlie Catlett leads this initiative, and there's interest really around the world for rolling these out. They are ultimately mounted on light posts around the city. Okay, transitioning specifically to what NSF has been doing for several years leading up into just this past year. We had been investing in all different ways in the research that underlies smart cities. This image just shows examples around a city of ways that data is collected, closed loop cyber physical systems, environmental considerations, economic and policy considerations. So this is really just to demonstrate that NSF has long been investing in pieces of the puzzle that form the smart cities research agenda. And then this past year in 2017, we launched for the first time a focused smart and connected communities program. The program is really centered on advancing fundamental science with deep community impact. And the community impact it should really be end to end. So we're encouraging researchers to work with the community to define the research questions, and then to work iteratively with the community to test out the solutions, the research innovations, and quantify the impacts and the outcomes in the community, ensuring that this research really sticks and has value for communities. The scientific innovations themselves, I'll get to this on the next slide, but this cycle of fundamental science and engineering with community engagement and community impact is what makes this program unique. It's really the key premise of the Smart and Connected Communities program. this is a bit of a framework, a conceptual framework for the way we think about the program and the solicitation. The key components in the purple box at the bottom that lay the foundation or the groundwork for the program are integrative research. That integrative reflects technical innovation, so big data, cyber-physical systems, infrastructure, systems engineering, for example, integrated with social science considerations, like the policy implications, the social and behavioral considerations of the community, the economic impacts. That integrative research really reflects integration of social and technical dimensions. And then secondly, the community engagement, this involvement with individuals and community organizations in the defined community for the research. And then ultimately, we're looking to ensure that these projects lead to both scientific impact and community impact. And that's really the goal for the program. Smart and Connected Communities is a priority for SISE. We believe that it's an important intersection between universities and stakeholders within the community that will ultimately ensure that these scientific innovations benefit the communities. And the hubs and spokes really offer a unique opportunity to see these partnerships, this integrative research that's deeply embedded within community organizations. So just, I want to keep an eye on time and make sure I move quickly enough, but just want to hit on a couple points and give you some examples of what successful research has looked like in the past year. As I mentioned, this interdisciplinary research, really thinking not just about the technical innovations that we're very familiar with in SISE and in engineering, but also those social science considerations. There's one project that stands out that we supported this past year that's looking at energy efficiency in homes and what are the incentive mechanisms moving, for example, towards college saving plans for children in the home that really encourage people to change behavior when considering energy efficiency and energy savings. And then, so that the incentives was the social science dimension, and then on the other hand, there was innovations in the energy systems. That was really an engineering innovation, for example. Community engagement for iterative research. That project, I'll just carry through with that example. That project capitalized on a building development that was going, a new housing development that was ongoing in a community. And the research team really jumped in, and it was the community who reached out to the university. And then they were able to find a way to embed the research into an ongoing community project. That really helps ensure that when the research, for example, when the research dollars end, how do we make sure that the innovations and the translation sticks? So jumping on a project that's ongoing in the community, has buy-in from the community, for example, can really ensure the efficacy and the impact in the community. A couple other points, integration across sectors. We acknowledge in this program the interdependencies between energy, health, transportation, for example. So we're looking for research and solutions that are considering those interdependencies and do not treat each application domain in isolation. So, for example, transportation, leaving out the implications of transportation on energy and environmental impacts, for example. The program is really looking for a diversity of communities that participate. All geographic communities are included or can be supported through this program, rural, tribal, suburban. It's really not just smart cities, right? These innovations in information and communication technologies can benefit all different types of communities. And I mentioned this capacity building for long-term sustainability. I described that a little bit on the last slide, but really working to build strong partnerships between the university and the community, and then enabling translation from city to city. So you might see on a large Smart and Connected Communities grant, many cities participating. And in fact, there's one research coordination network from this past year that has several U.S. cities and also several international cities. To quickly summarize, agencies across the U.S. government have been engaging and are coordinating smart cities and communities efforts that's been ongoing for the past few years. NSF launched in this past year a focused program on smart and connected communities that program built on pieces of the research puzzle that had been supported for prior years. Ultimately, we really do believe that partnerships are key to the success of smart and connected communities research. Sorry for all these notifications. And I'm curious, I'm happy to entertain some questions and discuss. I'm curious to see how the hubs and spokes may be able to uniquely offer linkages between the university and community stakeholders.
Thank you very much.
I'll turn it back over to you all with that.
Okay, thanks, Megan. Any questions? We have about a minute. Let me just, is there, yes?
I have just a quick informational question. At this time last year, the Smart and Connected Community announcement was out. I don't know whether there will be another one coming out soon. And so what's the mechanism for us to get to know more about what's coming next?
Sounds good. And Megan, did you hear that?
Yes, I did hear that. Thanks. So what I can tell you right now is that NSF doesn't, I can't tell you about out-year solicitations until they literally hit the street. So I can just tell you that it remains a priority for us. The way that one would get updates when solicitations are posted is via the SIZE website. You can sign up for updates, and it's on the left-hand side at the bottom of the site, nsf.gov/size. You can sign up for updates, and I just encourage everyone to keep an eye out and sign up for those updates. They push updates on all solicitations and all announcements.
Thank you very much. Thanks very much, Megan. Let's thank Megan for her presentation. Next up is Dave Golke at the Department of Energy. Dave, are you with us?
I am. Can I be heard? Mic check.
Yes, I can hear you. That's great. So next thing, do you have slides?
Yes, pulling them up right now.
Okay.
And let's see if this works. So you may see
yes
something.
Yeah, we see it. So you're ready to go.
Yes, absolutely. So first off, I'll apologize for not being Rachel Nealer. She is probably, if not a more elegant speaker than I am, certainly more engaged in the federal side of things. I'm actually a former AAAS Science and Technology Policy Fellow here at the Department of Energy. As of a month ago, I'm actually now a transportation analyst at Argonne National Laboratory. So if you wanted to see the icon, the logo for our lab, you'd have to pay closer attention to Megan's presentation, but at least it got up there during the panel, so I'm sure that my boss will be pleased with that. I want to talk, though, about why I'm here filling in for Rachel, is talking about what's going on inside of the Department of Energy, and specifically the Vehicle Technologies Office. So I definitely won't start with an organizational chart to show you everything that we've got going on. But I do want to give a little bit of context, and I apologize if the logo for the WebEx is in the way of the screen. Hopefully you can still see it. But just to add a little bit of context, we tend to approach things, we have a very specific mission. Our goal is to reduce petroleum usage, to improve energy security, things of that nature. And so that's the lens through which we look at everything. We look at these problems and we say, this is a great problem. Is that something that we should be focusing on? And in general, our focus is on transportation. So if you look up here, you can see on slide 2, transportation is the second largest expense for U.S. households. So the dollars out of your pocket, that's going towards your car and your transportation and your fuel and things of that nature. So that's kind of a pocketbook perspective. There's also the energy perspective. So this graphic in the top right, you can see that the transportation sector was passed by the electric sector back in the 70s. That continued to grow. But this far last 20% or so of this graphic, you can see that electric power is actually becoming more efficient. There's more energy efficiency measures in buildings and houses and things like that. While transportation did dip with the recession, fewer miles driven, it's actually back on an upward trend. So you can see a similar graphic for carbon dioxide emissions too, if you're interested. So it's definitely something that is important. It's definitely something that is growing in importance, particularly from a petroleum perspective. Trying to go to slide 3. There's a lot that's going on. So for the last 60 years, 80 years, it's pretty much been business as usual. There's going to be roads, there's going to be cars on the roads, and they're going to be driving. And that's basically as much as we've thought about it. If we can make the cars more efficient, that's great. But there's a lot more going on. There's population trends. There's demographic trends. There's technology trends. Everybody here has probably heard of Uber. Everybody's probably at least heard in passing of a self-driving car. These things are entirely fundamentally, potentially at least, shifting what's going to happen in transportation. I'm not going to list everything on here, but what we're trying to do is saying, okay, how are these trends causing this disruption, and what do we need to know, and what can we do to improve research going forward? Again, some of these were listed on the previous slide. I don't want to dwell too much on this other than to say, how can this disruption lead to new opportunities for us? And what can we do as the federal government, as the Department of Energy, to lead to the best possible outcome? So now we're giving a little bit of perspective into our specific office. So we are inside of the Energy Efficiency and Renewable Energy Office. So there's also the Office of Science, which does a lot of the high-performance computing traditionally. So here we are in that section. Our office is designed as such here. You can see that there's kind of 5 or 6 pillars, depending on your count. The far left side of this is what I like to call the stuff. So electrification, materials technology, advanced combustion systems. These are making your batteries more efficient, making your car more lightweight, making your engine more efficient. We've done a lot of work historically on this, and we're still doing work on that, but we're now starting to look, instead of systems in vehicles, at systems of vehicles, which is what this energy efficient mobility systems means. And so how can we look at things inside of that? Moving on to the next slide, here on slide 7, this is what comprises our EAMS setup. We're in the federal government. We need an acronym. We don't need it to be good. We just need it to be short. So here's EAMS. And inside of EAMS, we've currently got a handful of projects and some projects that are starting. One particular one that's ongoing, it's been going for just over a year now, is our Smart Mobility Laboratory Consortium. So there's 5 pillars here talking about the future trends in technology from a transportation perspective and what the energy impacts will be. Advanced R&D projects is things like actually having vehicles communicate with each other and seeing what kind of energy impacts we can get there. So that's kind of on the few vehicle level, 1 to few vehicle, or even looking at the components. The core VTO evaluation and simulation tools, that's long-standing. It's really understanding on an in silico level what's going on for these vehicles. We also do some on-road testing here, but making sure that when we do our modeling, we know what's going on. But for today, I want to focus more on these 2 on the right side. The high-performance computing and big data analytics, conveniently grouped together in the same box, even though they are complementary projects, and the EAMS Living Labs. So I'm not 100% certain. The last slide is the closing slide, so I'll just go with words here. I'll talk about the HPC projects. So the Department of Energy now has 4 high-performance computing for energy initiatives across the entire department. There's an initiative, HPC for manufacturing, HPC for subsurface, mining and things of that nature, HPC for materials, so if you're familiar with any kind of computational physical chemistry, that kind of thing there to improve the materials we have. We are interested in that, but we are taking the lead on HPC for mobility. And so they're currently in the selection process. I can both plead ignorance and actually truthfully claim ignorance on exactly where they are. But there are looking at being some national lab projects that are being funded on this particular thing. An example might be doing some kind of artificial intelligence-based transportation demand modeling. So that can be used to quantify impacts of future mobility scenarios. We published a report recently that said you might triple energy usage, you might cut it down by 1/3, but that was really meant to be a bookend study. This idea would be something of the nature of really diving in and seeing what the important things are. The other side of this coin is the big data analytics. And this is also national lab focused. The Department of Energy does manage, is maybe not the right word, definitely fund work at the national labs. And this would be having a way of applying big data to emerging large data sets. So we could, for instance, envision everybody's got their car or their phone with their GPS that's tracking them as they go. And we can envision saying, okay, let's pull all of that data in and let's use that to optimize the transportation system for some variable. The Department of Transportation is probably interested in safety and congestion. That's great. We love that they're focused on that. We're going to be focused on things like fuel economy and emissions and how can we minimize those? And what can we do to work with other labs, with other federal agencies on that? So we're looking at figuring out where these energy savings opportunities are, using the power of high performance computing and big data analytics. And so this last year, we've actually got a few projects that came out. These are all university-led. I believe the PIs are all at different universities. 3 were awarded this year, where they're really starting to, maybe not quite on the high-performance computing, the truly big data, but really trying to get impact from universities to do some of this research and say what's going on here. The other thing that came out recently was some awards for 3 particular communities for actual on-road testing and things of that nature. I don't have the details of all of these off the top of my head, but if you reach out to me or Rachel Neeler, I'm certainly happy to share what's been made public there. But this ties in with our Eames Living Labs, and this is related to things that have been brought up over the last half hour or so. Somebody recently said, you need to tie to the applications and uses of big data. You need to tie to the people who would be using these technologies. I didn't catch who said that on the phone a little bit ago, but I think that's absolutely correct. We want to be able to say, okay, here is a city. What can we do to help the city? Megan said, somebody on the phone also said, community of practice of these users before starting to build the platform. Yes, we want to know what questions they actually have and how we can help people solve the problems that they have. Megan mentioned community impact to define the research questions, work iteratively with the communities. And this is something that we're really focused on. We've been working on this with our technology integration. Stepping back one slide, we have technology integration. That's always been a core part of the Vehicle Technologies Office. Now we're linking that with systems level thinking. And how can we take that systems level thinking, what can we inform it with based on high performance computing and big data? So that's where I'll cut off now. Keep time for a little more questions if necessary. But basically, this is what we're looking at. We're new to the space, but we know everybody else is, so at least we're aware. But this is definitely somewhere where we think the trends are changing, and we want to be ahead of the game in order to really find optimal impacts. So there's Rachel's contact information. My email address is david.golke, G-O-H-L-K-E, also at the same end there. So feel free to reach out to us, and happy to take any questions. Thank you.
Thank you very much, Dave. Do we have a question for Dave? Dave, I wonder if you might just say a couple words about DOE works differently in terms of its funding calls and how you interact with the agency. For this audience, I wonder if you might just very briefly talk a little bit about how researchers can connect with you.
Sure. So one thing I will pull up, and it strikes me that I have the technology to do it. I'll put up my email address here, and I'll put it in a font that can actually be read. So my contact information, Rachel Neeler's, will also be on the slide. So that's what you could do at an office level. So the Department of Energy is very broad. So we have working groups with people in the Office of Science, in the Energy Information Administration, in ARPA-E, Advanced Research Projects, acronym /Energy. These are all things that we're definitely looking at. So there's not one fixed way of saying, this is the best line of contact for all of DOE. But within those different agencies, there are different ways. For this particular audience, definitely the work that we're doing in Eames is relevant. The work that's going on in ARPA-E is very relevant. They have two projects called NextCar and Transnet, which recently started last year or earlier this year. Both of those are largely, I don't know if it's exclusively, but many of the award winners there are universities. So there's definitely the focus there. There's also the Office of Science, and I haven't said too much about that, but that's really the elephant in the room. They operate most of our national laboratories, and they have a lot of funding that goes out towards universities and things of that nature. So there is I'm going to write the acronym and then try and find out what it is. It's OSCAR. It's their Advanced Scientific Computing Research. There are some people there. Their website's actually pretty navigable, so I won't try and drop names there. But they are the kind of people who have been doing big data related things for a while. They've got lots of different projects going on. We're trying in our office to say, okay, how can we utilize what's going on there? So we've got a few seedling projects. Those are mostly starting at the national labs, though national lab researchers are almost always happy to link up with universities. But OSCAR and the Office of Science is definitely a great contact to be looking into. And the other one that I noted is ARPA-E. And these projects are already funded or selected, but the Transnet and the NextCar projects are definitely of potential interest. And hopefully you can see what I've just typed up on the screen.
Excellent. Yeah, we can. Thank you very much. Join me in thanking Dave for stepping in as Rachel. That brings
Happy to do so.
That brings to a close our session. Melissa, how much time?
So we have time for a break now, and it's okay if we take at least 15 minutes. We'll just bump the next panel into the last little bit. So if we start again, it is 10:20. If we plan on getting the next panel started in about 15 or 16 minutes, that would be great. Thank you.
10:35 then. Thank you very much.
Renata, can you hear us? I can. Hi, Renata. Thank you. I realized I logged in at 10:30 Eastern time. Oh, well, and I could see that you were on, so it's glad we had some audio problems. So I'm really glad you're here and you're working. So I'm going to see. Dave didn't Dave, if you're still on, can you unshare? Hi, can you stop sharing your screen? Would you mind? Thanks so much. That's awesome. And Dave, thanks again. And Megan, thank you very much. If you all are on, you're welcome to listen in to the next panel, but no requirements. Thanks so much again for joining us for this panel.
we'll start with the final session. Admin announcement. In your blue folder, you should have an evaluation form. Please fill it out and put it in one of the boxes where you did the registration. So our final session of the day is Education and Workforce Development. My name is Michael Twydale. I'm at the School of Information Sciences at the University of Illinois, and I'm director of our new Master of Science in Information Management, which has now been going for just over a year. So I'm here very much to learn what we should be doing and how to do it better. And we've got a great panel to help me, and I hope also the rest of you in the audience will help out. Our plan is to invite each of our panelists to do a brief sort of position statement, 5 to 10 minutes of their perspective on workforce development, and then we've got plenty of time for question and answer. I've got some questions that I want to know, so anytime people don't put their hands up, I'll work through my list. And I will ask each of our panelists when they're presenting to start off by introducing themselves. So let's start off with Dr. Renata Rawlings-Goss. Take it away, Renata.
Good morning. Thank you, Mike. Can everyone hear me? See my slides?
Yes, loud and clear.
Perfect. So to introduce myself, I'm Dr. Renata Rawlings-Goss. I'm the co-executive director for the South Big Data Hub, which is a companion to the Midwest Big Data Hub. They're there for now. My background in big data is in computational genomics and genetics, and then I worked inside in the front office with Chiton and Fenn at NSF with the big data research program, as well as big data policy around the federal strategic plan for big data. And then with the White House Office of Science and Technology at the time, that was I started a program looking at data science meetup groups and organizations and how this effort around education that's non-traditional can affect social good and can be used for the benefit of the United States and bringing those people together. So someone mentioned earlier about models and how the different hubs may be different in models. So just briefly, the South Hub is the 16 states, Delaware to Texas, and we have a different model. Now we have 2 executive directors. I'm at Georgia Tech, and they have another executive director, Leah Shanley, at UNC. And today I'm really talking about our education and workforce working group that I'm chairing, but these are all of our other priority areas for the South, which are a little more fluid and also slightly different from the Midwest priority areas. So for me, data science, education, and workforce, this working group is really about building data literacy as well as data science capacity through education, training, and workforce development. Because for the working group and in my looking out, I also run the Director for Industry Partners for Georgia Tech Data Science, and we talk to a lot of industry about what they need. And it's really a problem of scale, which I think we all know, that there's just not enough people trained in a way that can accommodate the workforce you really need. And so that scale problem comes in a lot of different facets. So the working group does different programs and projects are housed under the working group, as well as kind of strategic direction, which is around 4 focus areas: institutional outreach, faculty and student development, workforce landscape, and resource development. So some of the things on this list are ways of getting at those goals. So first is surveying the educational landscape. So before I even started at the Hub, I was working with the SIZE AC committee and putting together a list of data science educational programs across the country, and looking at different sources and websites that are cataloging those, and did a little bit of text mining around where those programs were housed and what types of departments they were in. So you can see, based on the visualization, I wanted to visualize geographically where those were, and you can see a concentration around the coast. When there's so much industry, there's a a member of our advisory board that really talks about every company, no matter if they make shoes or supercomputers, is now a data science company in some way, in some fashion. And an argument can be made for cybersecurity as well. So with that, you can see the huge amount of infrastructure that would be needed for education, especially in states in the Midwest and in the South, where there's a huge amount of manufacturing and business need, but the educational programs aren't as concentrated as they are on the coast. And we can talk about all of these things later in the Q&A. I'm going to kind of go through an overview way. So one grant that I'm the PI for is this Keeping Data Science Broad initiative, which is looking at gaining where are some of these programs and how are they thriving at non-R1 places. Places that are more teaching-focused, community colleges, minority-serving institutions, because we know that workforce actually is predominantly being trained at these types of institutions, liberal arts colleges, four-year colleges, where a lot more of our workforce is coming out of institutions that aren't necessarily research one. So we want to be sure there's capacity there. So this was a webinar. You can view these on our YouTube channel at South Hub, and it's broad. It's over the whole nation. So there's people from the Midwest, from the West, from the South, looking at their programs. Also, one other thing that comes up a lot is not knowing what the industry actually needs and having that connection between industry and faculty. So this is a program that's TEPI that has run for the last 2 years, which is programs to empower partnerships with industry, where we've had faculty members. This is one of our 2016 fellows from LSU, early career faculty members, where they go for several weeks to work with the research team at a particular company. Because I get this chicken and egg a lot, where the faculty will say, I don't know what I can do with industry. If only they would share their data, I could tell you what I could do for you. But then the industry would say, well, I definitely cannot show you my data until you tell me exactly how you'll make $1 billion idea for us. So this is a way to kind of get around that chicken and egg, where you can see the data from the inside. And 100% of these faculty members actually want to continue their research relationship into the future with that industry partner. This is also one that's data science extension, which is being led by the chair of computer science at Spelman College, Brandeis Marshall, who's here. And it's really about taking faculty members who are in the Spelman and Morehouse College, which are both historically Black colleges, four-year institutions, and training them up in data science so that they can incorporate it into their current courses. So not necessarily creating data science courses, but incorporating them into the courses they're currently teaching. So there's 10 faculty that did a 2-week training, and then for the next year, they'll be incorporating data science into their courses and staying together as a cohort. Another aspect of the Keeping Data Science Broad is looking at alternative ways of education through data science. So not necessarily the traditional academic programs, but looking at programs like the Breakfast Group, which is on the West, which is a mentoring program, which is started by industry to mentor high school students. And also looking at putting data science in arts and humanities courses, which Leor, who's in the Midwest, was a fantastic speaker for. Sarah Stone, who's a co-director for the West Hub, and talking about data science for social good, which I know you had Rayed Gianni talking to you yesterday. Tracy Teal, who is director of data carpentry, which runs boot camps, data science boot camps, and then also museums. Stefan Uzo is the chief scientist for the New York Hall of Science, which does a lot of outreach for public data literacy and how to increase that among the general population. So this year, Atlanta, we have a data science for social good program as well. So the South Hub sponsored the graduate student component of that, which was really helpful. I think you get a lot. The students gained a lot and really form a network, which you've heard about before. Also community engagement around a VITAL series, which I'm actually pretty proud of this acronym. I may be the DC in me where I love a good acronym actually. So it's video, image, text, audio, and learning data, where it was a monthly webinar where each month we would just look at video data and bring in someone from industry, from academia, from different departments. For instance, the text mining one had someone from Career Builder looking at text mining and resumes, someone from the business school who is looking at text mining for executive language, how executives talk about different problems, and someone from urban planning that was looking at text mining for trying to decide which areas of the city to plan and where the best neighborhoods, as well as, you know, looking at text mining in scientific domains and in healthcare for medical records. So it was interesting, the techniques were different in the different fields, even though some of them were trying to do the same things. And so that education, kind of cross-education, really helped, because some people thought, oh, I didn't know they had solved that in that field, and I'm trying to do this. Maybe I can use these same techniques where I am. So lastly, there's some new programs that we're looking at trying to do this year, which are two. One is called SnapDS, which is stimulating new applications and projects in data science. So it's a little bit about what Chaitan was talking about, where we want to facilitate planning grants, as well as the ability for people to collect and convene data. So not necessarily data gathering, but more data synergies. So if there are different places with data and they want to convene, we're producing travel support so that small groups can get together in conjunction with scientific meetings or current conferences to do some of these planning activities and to produce more of a streamlined document where they could be applications for spokes. And then just recently, part of receiving another grant, which the lead is going to be Kevin Stosson from Vanderbilt for NSF Includes, which is looking at creating a pipeline for retention of students in the physical sciences and engineering, which has, you know, been historically not as diverse. My original degree is in physics, and that is usually not a field that has a strong diversity in women or underrepresented minorities. So kind of creating a pipeline to do those processes. So I'm going to stop here in terms of time to get it at exactly 10 minutes. But if there's any questions, please feel free to ask in the Q&A. And if you want to be involved in these activities, you can see that a lot of them aren't just in the South. There's been a lot of participation from the Midwest. Melissa has been great. So I would encourage you to reach out to her if you're interested in this or in projects you think may be complementary. And she can definitely connect you with me as well as some of the things that are going on. And so my email is here if you want to also reach out directly. Thank you.
Great. Thanks, Renata. So, do you want to come up next? So we'll save up your questions. We will handle the large Q&A at the end. Let me just move over the slides. And if I click on that.
Thank you. There you go. Hello, my name is David Moncho. I'm at The Ohio State University, where I co-lead, like Renata, co-lead an effort, but as our Institute for Data Science and Analytics, which we refer to as Translational Data Science and Analytics. And I'll say a little bit about that word in a couple minutes. This one. That's it? Okay. Is that better? Okay. So my introduction to data was in the... I'll try to be shorter. Is this better? Okay. To data was actually in the 1980s at Carnegie Mellon University, where I minored in data analysis. I wanted to be an English major, which I was, but realized that there was some value in understanding quantitative approaches to problem solving. And then I worked at Bell Labs for quite some time, and it's interesting, isn't it, that a lot of times we'll hear people say that big data, data science is not new, and I tend to agree with that. It's just evolved and become something different than it was before. But when AT&T went through divestiture and trivestiture, a huge issue was data mining and data cleansing of all the subscriber records. The government decides to break something up without thinking about, well, how are we actually going to manage all these huge information systems that are behind the telecom network? But I have to give a disclaimer from my work at Bell Labs, and that is I got involved in education and training, and there was a view that as AT&T had to become more competitive, that engineers needed to understand competition better. So I worked on a course about competitive engineering, which focused on benchmarking, competitive intelligence, and reverse engineering. And our targets around experiential learning exercises were how to beat Alcatel and Nokia. Well, unfortunately, take what I say with a grain of salt, because the outcome was Alcatel and Nokia bought us. So, the Translational Data Analytics Institute at Ohio State, it's a long-term commitment that we have with a big focus on solution development and talent development. I'm not going to spend a whole lot of time describing the Institute. I'm going to focus on one aspect of what we're doing, which is our looking at the university-wide educational investment. And in that activity, just so you have a sense of our orientation at the university around the education, we've bought into this notion of translational data science. We heard the NSF about the workshop earlier. Well, in 2014, we started to talk about this whole notion of should we focus on the aspect as a land-grant university of being able to translate our science to have societal impact and practical importance. And while we don't do that to the exclusion of foundational sciences of math, stats, comp sci, for example, we are very much focused on can what we're teaching lead a student to create a solution to a problem that matters. So in the abstract for today, there's a mention of a case study. And I'm going to talk a bit about our case study and about how we're approaching this one aspect of what the Institute is charged to do, which is looking at the university-wide educational investment. And what we're doing, in some ways, as I share, my background is out of industry, and the idea at Ohio State was, can we combine somebody, can we bring a faculty leader with somebody from industry, and maybe there's some positive interactions, maybe there are some tensions that could lead to a different kind of solution that we're developing. So in the educational investment space, we took somewhat adopting ideas of product development, portfolio management concepts to think about how we're managing this investment in data science education. So 2 years ago, we, like many large universities, we didn't even have a handle on what was available. We knew we had one of the first undergraduate majors in data analytics. We got a lot of attention for that, and that program has great success now with sophomores basically being placed in jobs. The competition is pretty fierce. So we did our own analysis, but then back to the work I did on reverse engineering, benchmarking, and competitive intelligence. I guess I'm a slow learner because that didn't turn out too well. We also looked at how we can get more information. So we work with the Business Higher Education Forum, EduVentures, and local economic development groups to make sure that we didn't have an insular view of what was needed in the space of education going forward. And we developed a report, which we then shared in faculty and student listening sessions, very much believing that if the university is going to have an impact on data science and analytics, it has to be well understood. And we have to listen to the voices of the students who are seeking jobs, the faculty that are helping them get there, or students who are seeking to do advanced research and the faculty that are supporting them in that. And that brought to bear this idea of you can preserve, that I also took from Bell Labs, you can preserve the integrity of the lab while providing a product execution. One of the takeaways I think that's important from our discussion today, and we saw this a bit from what Renata talked about, there is so much need that there's place for everybody to play, all the educational institutions and industry working together. And we don't have to sacrifice academic integrity by getting involved in the areas of training and workforce development. I don't think the large R1 universities can just think of, well, that's the job of the community college. That's a job maybe of an R3 local school. And we heard some of that earlier, and I think that's something that should inspire us because, again, there's plenty of room for all of us to play. So the three pieces of our looking at what we were doing at Ohio State and what we might need to do next. We determined through our internal assessment that we had 21 degree programs and 9 minors that somehow touched data science and analytics, including the undergrad major that I mentioned. And we're probably behind many of the other universities in the room in terms of certificate education, but we're increasing in that space. And the report led us to think about what else we wanted to do. And as you can see, the undergraduate degree is quite nimble. So while it's focused on interdisciplinary work, it also very much has a focus on industry segments and industry problems. So while we had a biomedical and a business and computational science track, we're now introducing social analytics and visual analytic tracks. And that is one way to keep attracting students by providing different tracks for them. But we also realized in some of the work that we see in the next 2 reports I'll share that we needed more graduate education. And I'm going to talk specifically about what we're doing around a professional science master's. So that was our internal skin. The second piece was we participated with the Business Higher Education Forum in Washington, D.C. and PricewaterhouseCoopers to look at the whole issue of national talent development for 2 types of positions, data science jobs and data analytics jobs. The professional science masters that we're looking at is focused on these analytics-enabled jobs. And some of the guidance in this report is that a good way for industry and university to come together is to invest together in market-driven programs, and also to find a mission that matters together. So it's very interesting to me that we could have, like all university industry, you get together, you talk about the great things you could do together around talent. But then when we started to say to local firms in Columbus that also care about some of the things we heard yesterday, local firms that care about, they want to contribute to stopping the opioid epidemic. They want to contribute to improving infant mortality because they'd love a headline that says Company A in Ohio State helped solve this problem by bringing data science and analytics to bear. So finding that mission space is something that I think all of us can learn by looking at who sits around us where we're educating, what companies sit around us. These are the 8 findings in the report. A couple things about them. I'm probably going to skip in the interest of time. I can give you a link to the report if you were to contact me. But it appeals to things we should both do in business and in higher ed. A big piece of this is why I say we all have a chance to play is if we looked at what Ohio State is able to produce today out of those 21 programs and 9 minors, you can see the numbers on the chart that show how many students we're producing. Well, this is the demand side of the equation. So just in Ohio, 81,000 jobs that we're calling for data analytics and data science capability, and just in Columbus metro region, 13,000. EduVenture analysis showed something that's really pertinent to the Midwest Big Data Hub. The demand in the Midwest region is growing 3 times faster than the number of programs that are coming out. So Renata showed us a lot of programs, but this is saying there's need for more. So our approach with the business, we had the faculty roundtables, the student roundtable. We had these external sources that we tried to use to inform our work. And then we brought in the experts. This was something that was brought up yesterday during the keynote, that don't just jump to implementation, have a conversation with the stakeholders. So we brought in experts, we talked about design. All these firms have some sort of local presence, whether they're headquartered or not in Ohio, in the Columbus region. And we also thought it was important to bring into the room a behemoth like Cardinal Health, one of the Fortune 10 firms, with a Cover My Meds, a very successful startup. So we're going to hear differing points of view focused on this data analytics-enabled professional. We were not on this degree trying to develop data scientists. So our approach going forward, what did we hear from these firms? Experiential learning component to a degree is not sufficient. In the PSM, the basic message was, can't you work with us to come up with an experiential learning program? Not that we offer a capstone, not that we do a project in the last semester. What can we do that the entire program is linking the firm with the university? Second was not one course in problem thinking and critical thinking, but how do you underline all the courses to cultivate curiosity and critical thinking? How are all the faculty supposed to stimulate that in whatever discipline they're teaching? That led us to an idea of having, and this goes back to, say, the product development approach to curriculum, a controlled introduction, very common in industry. Before you go out there, test it. So we're talking to some of these firms, trying to find the win-win. If you invest with us, back to the BHEF report, looking at how to invest together, if you invest in this university and you identify students in your company that we can put through this program over the next 2 years, let's find a group of companies that want to do that before we open this up broadly. And let's iterate on the curriculum and be more responsive to needs. And then another hurdle that we constantly hear about is, but what about data sharing? If you do this controlled introduction approach, you have these students connected with a particular company, taking their experiential learning with the company. We have this notion of bring your own data. We don't have to overcome, well, how are we going to set up a VPN? How are we going to do these things? Those students are likewise interns or so on with the company, and that helps solve part of the problem. So these are some of the things we're doing at Ohio State. And the final point that I want to note is something else that came up in the past 2 days and last week at another conference. In addition to part of what supports talent is having a place, just like us joining here to talk together today, we've heard time and again, if industry and students and faculty had a place to work together. So we have the benefit at Ohio State that we have that place, but that's something that we could all do to contribute further to data science and analytics education. Thank you.
And our final panelist is Jim Barkley, and let's see how good I am at turning off slideshow. Apparently not. Oh, well done me.
Yep, thank you. All right, try not to look at this chart for a second. I know, it's kind of hard not to look at, huh? My name's Jim Barkley, and I moved to Chicago about 2 years ago from the Boston region to work at one of now 13 national manufacturing institutes in the Chicago area called DMDII. And it's housed by a nonprofit that focuses on public-private partnerships. And so I have a little bit of a manufacturing flavor to some of my thoughts. But just recently, as I was there over the last couple of years, I realized how dramatic the talent gap is, especially in the Midwest, at least compared to some of the areas in the coasts. And so I've recently just started my own company to try and address some of those. So that's where I'm coming from. I don't have too many slides, just enough to be provocative, I hope. Data science is not new. I'm glad you said that, because that was where I was going to start. But economists have been doing data analysis for a long time. Back in the 90s, I worked with the National Oceanic and Atmospheric Administration. This is a group of scientists that are really profoundly excellent data scientists. And going on before that, all of the things that happened at Bell Labs, World War II had some really fascinating data challenges. So, it's not a new space. But what is new is the explosion of data. And now you can look at this chart. So this is, has anybody seen this before? Hands? Okay, a couple of people. Well, it's really the availability of data that's changed. You know, back in the old days, you had to design an experiment just to collect the right data. And the time cycles for doing data analysis were very long, and that was part of the reason. Sometimes that's still necessary, but it's much more common now to be overwhelmed with data and try and figure out what to do with it and make sense of it. And that's what this IoT thing is all about. You know, we have decided to instrument every aspect of our physical and virtual worlds. And that's what we're trying to do today. It's transforming a variety of different verticals. That's kind of up at the top. But it's also creating a whole bunch of new startups and innovators that are really data companies, if you think about it. Yeah, and, you know, if you're a Kurzweilian subscriber, and I tend to be, you know, really we're learning how to augment our evolution and our environment, the evolution of our environment with our technology, from Fitbits to smart cities, right? And this is giving rise to the demand for more data scientists. But saying we need more data scientists is the wrong question, in my opinion. That's like saying we need more doctors. You know, the doctor shortage in the 1960s was not addressed by more doctors. It was addressed through fundamentally rethinking how we administer care and what those regimes look like. And, you know, the nurse practitioner was born out of that, and other things like that. And that's really where we're at with data science today, in my opinion. This is the kind of workforce revolution that we're seeing. The demand is outpacing the supply pretty radically, and I think it's projected to be one of the biggest skills gap in the next 20 years, along with cybersecurity and some other flavors of engineering. So what does that look like? Well, this is an example of how we're kind of rethinking that whole landscape. So this, yes, I know, it's another eye chart, but I'll walk you through it. This is some work that came out of the Digital Manufacturing and Design Innovation Institute. They have a workforce development component at UI Labs out in Chicago, and they worked with a company called the Manpower Group to think about what are the next generation of manufacturing jobs going to look like. So there's about 165 different roles defined across some of these key areas, things like digital thread, digital enterprise. Many of these have a data science kind of component to them. There's a well over 100-page report on this at uilabs.org on the website if you want to hear more. But one of the interesting things is that you know, a lot of the roles defined are things like collaborative robot specialist or enterprise digital ethicist or predictive supply networks engineer, right? And so these are almost specializations of data science, which get really interesting. And the World Economic Forum estimates that by 2020, about a third of, and let me just read this quote because I don't want to get it wrong, about a third of in-demand skill sets in most fields will require skills that aren't considered essential to that job today. So that's less than 3 years away, and jobs that are considered essential for, skills that are considered essential for a third of jobs today are not going to be relevant. Pretty fascinating. And that's from the World Economic Forum. Now, if you look at the kind of paradoxical nature of this, that's really interesting to me, this need for specialization and diversification is really rapidly expanding, but also the need for convergence and integration, right? And this is something that we see in biology too, actually, right? Diversity of the species and everything leads to advantages, but then also integrating those things into a symbiotic ecosystem, or an ecosystem which has patterns of symbiosis, is equally as powerful as an evolutionary force. And so, you know, people entering the workforce should think about if they want to be specialized or if they want to be more of a generalist playing some of those integrator roles. But I think that's a big trend we're seeing. You know, so that's all on the kind of the demand side. On the supply side, this effort at DMDII was paired with a set of open courseware partnering with Coursera to do a series of digital manufacturing and design modules. And if you complete all of those modules, you'll be awarded a digital manufacturing and design certificate. And this is a trend we're seeing more and more as well. You can head over to Udacity and get yourself a nano degree in data science, which I think is a couple of 2 or 3 month modules. And so people are starting to rethink how we can think about what the fundamental nature of work is, what qualifications people need. The other one, though, is that people have, the data scientists that are out there, the tool builders, they're also building tools to be able to do their jobs faster and better. And so, the nature of work is changing, the nature of education is changing, but our relationship with our technology is also changing, and it's evolving into a partnership of symbiotic capacity, which in my opinion is really one of the only ways that we're going to be able to scale to meet the demand in the next 2 decades. So that's it. Let's get to some Q&A.
Great. Thank you very much. So, thank you. So if you've got a question, put your hand up. Melissa has a microphone. Please speak into the microphone. While you're thinking about questions, I am going to start us off, if I can figure out how to do this. Bring Renata back. I'm trying to. Yep. So I drag that over. Oh, I think I've dragged it the wrong way. I've broken it. Okay, somebody fix that. So, meanwhile, my question to all the panelists is, as I mentioned at the beginning, I'm in charge of a new degree, and I went round talking to a few employers saying, what do you want? What should I be teaching in this new Master of Science in Information Management to improve the chances of my students getting a job? And this is obviously very ad hoc, you're the experts, but one thing that popped up time and again were answers that were sort of big picture. So employers would say things like, well, they obviously have to have the data analytics skills, but they also then have to turn those results into actionable results and explain things to our senior management who are not data scientists. So, it's necessary to have the analytics skills, but it's not sufficient. So I put it to you panelists who've done this much more than my little ad hoc sample, are there other kinds of things that employers are saying they want that sort of fit in this big picture setting? And I'll start off with one of the people in the room, and then hopefully I haven't totally broken it and we can bring Renata back. Okay, you've got it.
So hearing two things I pointed out for the professional science masters that we're hearing are not novel or unheard of before. One is the importance of experiential learning, and the second is this notion of critical thinking. I think what's novel, though, is what industry is saying. Again, I mentioned, we don't want a course in critical thinking. We want critical thinking to be a unifying theme across the entire set of courses that make up this degree. And similarly, experiential learning, not to just be a project at the end of the degree. In terms of the other thing that we've heard very much, and I think we all buy into, is the notion of storytelling. We've heard time and again, and storytelling is part of the undergraduate degree program, that what we hear is if you can't understand what's driving the C-suite and how to make them understand what you discovered and why it's relevant, and in turn educate the C-suite to ask the tough questions, then we're not going to have the impact that we'd like to have.
I think we've got Renata back yet, so on to you.
Yeah, I think that's pretty well said. I mean, experiential learning is something we hear a lot from employers. The last piece, though, that you mentioned, I'll just reinforce. I think it's really critical to educate the C-suite as well. It's You know, it's true that communication of results is really critical and can be very difficult, but at the same time, I would also challenge business leaders to expand their thinking and understand some of the fundamentals of statistics and analytics, because if you're a company today, you're probably a technology company in one way or another.
We have a Yeah, so I'm Carl Schmidt from Valparaiso University, since I haven't introduced myself earlier on questions. Mike and I were talking a lot about some of these things, and I have a sort of similar question, but perhaps phrased in a different way and getting at a different piece.
You will
So,
now be placed into conference.
Sorry.
To mute your line, press *6. To unmute, press #6.
Okay, we should hear you now.
do we have Renata?
Yes.
Hey, she's back. Great. Okay, perfect. Now this will go to everyone. Awesome. Certainly what the landscape for education looked like over the last couple years, and certainly employment, was that companies seem to want people to hit the ground running right away as soon as they hired them and be able to give sort of insight and things. And regardless of what that desire might be, we all sort of know that the scope is changing and that there's going to be entrances of people that are not already coming in with a bunch of experience in addition to the analytics knowledge and skills. My question, though, is from your experience or from your investigations with companies and from looking at, especially for David, for you, for generating this sort of landscape entirely at Ohio State, where do we draw the line in education between things that say we've prepared a student as well as we can to go out to a job, and then the company is going to pick up the training for specialization, or, and I mean, this could be I would prefer not a mile-high view, but it could be there, where, I mean, we could talk about things like how deep into techniques should we really be teaching students, because depending upon your industry, the techniques that you use are going to be very different, but there are obviously some very core techniques that perhaps we should say every data scientist should know. So can you guys talk a little bit about where the educational programs should sort of help students land in terms of skills and expectations of where industry might then be picking up training levels? Or do you guys understand what I'm asking about, at least? It's not well articulated.
I'll call on Renata to answer that. And while she's thinking, let me apologize for wrecking this and note, here's a little usability lesson for you. I teach UX design. Why did this go wrong? Because I was trying to talk, attend to the audience, and deal with technology all at the same time. And technology that's optimized, if you're only concentrating on the technology, is just fine. But I was cognitively impaired because I was mostly looking at you guys. And that's why I broke it. And that's why you need to test things in the real context of use. Anyway, little usability lesson. Back to Renata to answer the question.
Yeah, thanks, Mike. No, I completely understand that. We had a lot of webinars. It's cognitive dissonance. But to answer your question, or the question of the that was just posed about industry and kind of the line around academia, I would say, well, this is not a solved question. I don't think it's solved. But one thing that does come up a lot is, as before I got cut off, with communication skills and turning them into action. And one thing that I try to encourage companies to think about, instead of data talent, of thinking about the one unicorn person that can do it all, is that they really are going to have to hire teams. And students are going to have to learn how to work to get jobs done in a team format. Because, as you say, it's not feasible unless you keep students for 5 or 6 years to train them on every single technique. And even if you do, they're changing and emerging and new. And then you have to keep retraining your faculty to change on every single new technique that comes out and how to best use it. And that's a huge cycle of continuing education that we don't have in every discipline. And we certainly don't have the infrastructure in place for that now. But there are certain things that come up a lot, which are this ability to turn it into actionable insight, which really requires a deep knowledge of the domain, which is something we're not teaching in the data analytics, because we don't have the expertise in every possible domain to know which pieces will be actionable. So I think that critical thinking piece is really, really key, because you need to be able to say, this is a broad scope of the different techniques that are out there, and these are kind of the good and bad of them, and maybe evaluating, having some position where people evaluate what is the best technique for this type of problem. How can I work with a domain expert that doesn't have these analytic skills to try to explain that? And how can I work with someone who has a deeper knowledge of the actual technique to implement it? So at least those three components are necessary, and we're trying to find them and house them all in the same people, and not really giving people the skills to say, this is your piece of the puzzle, but this is just my own personal disclaimer opinion, but this is your piece of the puzzle, and part of our training is teaching you how to work with these other two pieces. And I think that's much more effective in reality because of the different, very vastly different skill sets that are needed for those things. And also trying to line that up with expectations from industry, I think it's also difficult because they're thinking all of those should be in one person, and we should be able to rely on them to do that, which you can, but then you have this huge shortage.
Panelists? Two points to the question. One is, having the conversation with industry. So Ohio State and IBM pursued a grant opportunity together where we tried to say, where do we draw the line between education and job training? And try and figure that out together and take it from an economic argument. How can we make this the most economically efficient university course and workforce training? So that was one thing. Second is, at universities that are fortunate enough to have a center or institute of some sort that goes across colleges, we think we don't want to dictate what the master's in applied stats feels is absolutely necessary to graduate with that degree. So the Institute's filling a gap by saying, but you know what? We're hearing from industry that they wish some students could come out who understood analytics at the edge. So we'll partner with an industry player to develop a program that gives the student choice to show up on a Saturday and try and get this short course or certificate even. So that's one way to start addressing these issues, is complement the degree programs with other things.
You want to? Okay, I have a question over here.
Thank you, Dan Lindsell, University of Nebraska. So this is directed to, I forget your name, I'm sorry, Ohio State, and I'm an alum, so that's pathetic, but I apologize for that. Is there an intention to have this data analytics major be accredited in any shape or form? And if yes, what could that do? And I'm bringing this up because in my field in engineering, we're all accredited. We just finished our, the group is ABET, and that's a 4-letter word. We just finished it up, and my bias-dependent accreditation stymies innovation. So I was just curious if you had any.
So initially for the PSM, we, of course, will go through the review by the Ohio Department of Education. And then secondly, PSM degrees in the U.S. have to pass a review by a professional association, the PSM. So we'll do those two steps initially as a validation of content.
So I'll just chip in and then pass over to Renata. So ours is a new master's degree. We've chosen not to explore any kind of accreditation at this stage, precisely for the reasons you raised, that we want to be constantly innovating because we're learning as we go. We market it to our students. This is a startup degree, so we'll get things wrong. We'll move fast, break things, discover this. We have a long history with our other flagship degree, the Master of Science in Library Information Science, which is accredited by the American Library Association. That affords us huge credibility. Students can get jobs with that accreditation, but there is an inclination for a break on innovation. And sometimes it's not even the accrediting body's fault. It's people say, oh, we daren't do that because the ALA might not like it. We haven't even asked them, so there's that fear of what the accreditors will do is, one of the bigger issues. So I would, if there's going to be accreditation, it needs to allow for rapid innovation within some sort of framework of, is what you're doing broadly okay. I'll pass over to Renata. Any information on the various things that you've seen on issues around accreditation?
So I can speak probably to the Georgia Tech accreditation. So we have several programs, a couple masters and certificate programs, a master's in science and analytics, business analytics, and computational genomics, these other things. And some of them have been accredited for the reasons that you say. And there's one that hasn't been because of the fact that they're really doing a lot of innovating with an industry advisory board. And so some of the tracks change as well as the focuses change from year to year as partners are developed. So I see the flexibility as being an issue, as you said, for accreditation, but also it's really important to, if you don't have if you choose to go the non-accredited route, is that you really have a strong tie to workforce, because that way it's a direct link. These are the companies that are a part of our executive board. These are the ones that have been there with us from the curriculum development side, and they're the ones that are going to have a vested interest in these students. So there's no disadvantage to the students. And in fact, we see that, so there's 100% employment rate at the end of that program.
Any other questions? Please put your hand up. I am going to raise another one with our panelists, which is helping actual students and prospective students understand what is data science really. So I found with some of our existing students, they come in, they've heard about big data, they want one of these jobs, it pays lots of money, and their impression is, I need to learn Hadoop. If I learn Hadoop, I can get a job. That's all I need. Why are you making me learn all that other stuff? Is it just because you do research on it? So we have students in the program who are very excited about learning things that they believe will help them and are somewhat skeptical about things that they don't believe will help them. But then the flip side is I think there are other prospective students who don't apply to study with us because their stereotype of what they think data science is doesn't match their interests. And I think, no, you're wrong. Data science is that thing that you're interested in and not that thing that you think we do. So misconceptions both of students we've got and students we haven't got but we'd like. Start off with somebody here.
Sure, I'll start. I think it helps. It's a big space, and I think it helps to provide people with some frameworks to understand that space and figure out where they want to play in that space. A lot of people think data science is, you're a hacker, you're a coder, and I don't like coding. Other people just want to be doing the pure math. Other people are the coders, but they are worried they don't have the statistics background. And then there's the technology side of it. And I think it was IBM that put out this really great map of kind of data storage platforms. And it talks about, it's got NoSQL and more traditional relational systems and then how those are evolving. And it kind of paints that full picture about where Hadoop fits in to that overall evolution of the technology to support the business outcomes that people are trying to affect. And sharing that with people just gives them some bootstraps that they need to help navigate where they can fit in terms of that space. And maybe they don't need to know it all, but it's not because it's irrelevant. Maybe it's just because their interests gravitate them towards something a little different.
Renata, do you have something you want to share on this topic?
Sure. I think that's a great idea of giving a landscape, showing where different pieces fit in. I was going to also say bringing in speakers from particular industries or people that can do that for the students, because I think that would be helpful in framing it. We find also that a lot of the students they come into, especially places like tech, and they think, okay, this is what I'm going to work for Google. I'm going to work for Google and Yahoo, Microsoft, IBM, Intel. And that's my ambition here. And they don't think about the manufacturing jobs. They don't think about the healthcare companies. They don't think about those as viable options. and they sometimes don't pursue them for those same reasons. So we also try and bring in different industries to get a sense that, oh, there are the same amount of interesting problems, technical rigor, groups and cohorts in these other types of areas that aren't going to be what they see, even if it's not Hadoop, what they see as data science companies that are really doing things and moving and shaking in this field. So I'd say that, and then also the new students, bringing in ones that don't apply is a little bit of a harder thing, and that's something that's a part of kind of the keeping the data science broad, this idea of bringing the data science to them. So putting it in the arts and humanities classes, putting it in the communications classes, putting it, taking it more into the fields where you would want more people to apply, and into those avenues in order to try and change some perceptions there, or at least dispel some fear that I don't need to necessarily sign up for a data science course. I can sign up for Introduction to Psychology and get, text mining or visual analytics as part of it.
Thank you. David?
Two quick things. One way to deal with the students to help them understand is reach back into K through 12. So we, for example, will have a program about women in data science and find some meaningful activities in summer programs so students can become used to what this even means. Second thing is let students tell students. So a lot of times a student doesn't want to hear from a faculty member. They can identify more with somebody 3 years older than them. And we have a very large student big data analytics association. Putting those students in front of the K through 12s and also in front of other students at the university is a good way to help people understand what they can do.
Thanks. Any last questions? As we have.
So within our departments across campus, there are different interpretations of what data analytics and big data means. In the context of education and trying to show what it can do, we have the same problem as we have with workforce, in that if you train us, then we'll show you what we can do with the data. But within departments, it's an even bigger issue because they're the ones who have to approve those certificate programs, those courses, and there's a bit of education that needs to happen within those departments. I was wondering if the panels have insights in how to engage and how to maybe speed up that process of educating our own peers about these methods.
So the challenge of explaining what data analytics is to our own peers in our institutions. Anybody want to? David?
I would just like to thank my colleague from Ohio State for giving me a homework assignment about this, because I don't have a ready answer.
Renata?
Yeah, I'll chime in here. I would say that you hit upon something critical. And just expanding the doctor analogy that was there, where doctors can sometimes be the worst patients, faculty can sometimes be the hardest sell for data science, just because they're experts. We're experts. You know your field, you know what's necessary, you've been doing it, and you really don't see why this is different, than the data analysis you've been doing in the past. So sometimes it's always good to have peers, just like with students, to have faculty that have done it or departments that have done it and showcase those successes to your peers, because then it kind of builds a little bit of the competitive spirit, in a sense that, okay, they're doing it there, they're having a lot of success, they're having a lot of student engagement, and it's something that we definitely have the capacity for, and I can see it. So some of that is also helpful. Again, I don't have a silver bullet for this question at all. This is something we do have to work with.
Yeah, I'll just add, it is very difficult. I mean, it's a big amorphous blob, sort of like cybersecurity, right? And it's emerging, and so there's not a lot of standardization of language or even, organizations around it. But that'll change over time, and who knows, maybe one day it'll even have its own, NAICS code.
Okay, well, I'd like to thank all three of our panelists for their insights. And if you want to ask them any other questions, come down here after some final announcements from Melissa. So if we can give a round of applause to our panelists, please.
Well, thank you, Mike, and people can talk to Melissa in lieu of me.
Thanks, Renata. So thank you. Please feel free to mingle. Thanks. And okay, let me get. We'll let you go, Renata. Thanks a lot.
Thanks. No problem.
Okay, so I just have a couple of wrap-up things. So first of all, thank you everyone for coming. I think this has been a tremendous meeting. I hope all of you have found some value in attending in person, and I hope the folks watching elsewhere have enjoyed the program and content as well. I want to thank the Kiewit Corporation for hosting us. This is a tremendous space. And the support for the AV and IT has been great as well, and we're really appreciative of this new potential partnership as it's developing, and the contributions they've made to host us this week. So thank you very much. Additionally, I would like to ask that please, if you're able to fill out your evaluation forms. This is really helpful for us in thinking about how we're scoping our work. It's an opportunity for you to give voice to ideas and areas you think we should be focused on, and the work we should be doing more broadly, and ways we can connect to additional partners and collaborators. So please fill that out if you will. There are blanks if you've misplaced it. We have extra ones out back. I want to thank the team on the ground here in Omaha and from Lincoln. Thanks so much for your contributions and support, and the work in helping us put this together. And of course, the team from the Midwest Big Data Hub. So thank you, and we'll see you next year.